Hello everybody, welcome to another stream. How we doing? Why does the camera feel so off? I don't know. Hopefully it's fine there. But yeah, welcome. How's everyone doing? Um, so last stream we got the tile binning code working, and so we're able to upload ellipsoids from the CPU. They get binned into screen tiles. Each screen tile has its own array of ellipsoids, and yeah, then they get each pixel looks in the screen tile, the array per screen tile, and we'll render these two ellipsoids. And we've got that working for all of our three different renderers, the RTAA, MSAA, and SSAA renderer. Yeah, so today we're going to optimize it and generalize it, because I think there's... so when they get really big, there's a very slow piece of code where we do like a n times m complexity like loop inside a shader. So you can see that if I just pause, get it to pause. There's this bin ellipsoid that's taking 1.2 milliseconds. Yeah, that's really bad. So that is it's emitting tons of yeah, it's emitting tons of ellipsoids into a buffer for every single tile that it intersects, and it's doing it on a single thread of a shader, so all of the other threads in the wave are just inactive, and it's just horrible and slow. So yeah, we've got to defer that into a separate pass and just make a very fast shader which basically duplicates data and changes it a bit. Duplicates some piece of data and changes another piece of data. So we'll go more into that problem later on when we actually solve it. But first, what I want to do is just generalize this bit of code, because we've been writing these tile binning things a few times, and I think this is the one that I want to, this is the sort of way I want to do it. And we've got a UI renderer which has its own tile binning set of code, and I have this ellipsoid binner which I've just written again. And I think I want to take this one, make it into a nice function we can just call, and there'll be some custom bits that you have to do for every time you bin something. But for the most part, there'll be this shared bit of code which will help us yeah, have just one way of doing it. So just be nice. Just be nicer. So we'll start there. So I guess we can talk about like do a brief recap on how the current one works, and then we'll get going with the generalization. So we look for tile bin. So effectively, this shader called tile bin ellipsoids, and all it does is go over every single ellipsoid that we upload from the CPU. We've just got two here, and it just gets this screen bounding box for them, and it will then emit. This is the one that ends up taking its time. Right one, isn't it? Yeah, it gets a screen bounding box from the local space AABB. It transforms that all into screen space and takes that. It's a rough guess, but it's definitely encapsulates the local space ABB. And then we've debug drawn this and seen it in past streams. So it's doing 32 threads in a thread group, so that matches a wave. So there's 32 threads running in lockstep, right, doing this code. So what happens is, this is actually the reason why it's slow, and I said I'll cover it later, but we're covering it now, I guess. Here's that sort of n times m complexity, where if you span a very big region of the screen, and right now we've got 8 by 8 sized tiles on like, this is a 4K screen here. But that window wasn't 4K, it was in between 1080p and 4K. So we're covering a lot of tiles, and it's doing this on a single thread going over all of those. So it was just pull a number out so we can see it. So if we've got, let's say that is, oh, I pressed the wrong, okay. So let's say that's how many screen tiles you have on a 4K screen, right? Going across. So, and then, yeah. So then let's just say going down the y-axis is something like 260 tiles. You have 100,000 tiles, right? So it's like 100,000 entries to emit inside a buffer on a single thread. That's going to be very slow. And yeah, so we want to pull this out and put it into a separate pass somewhere. Yeah, so the ultimate job of what this has got to be doing is emitting these sort keys and payload. So the sort key houses the tile index in the high bit. So when we sort this whole array, the thing it gets sorted by first is the tile index. So that means after the sort function, everything within the same screen tile will be next to each other, every single ellipsoid that we've emitted. And then the second bit we want to sort by is the depth. So that'll be in the lower bits of the sort key. But then there would also be sorted by their depth inside the tile. There's a nice little trick, but you just got to be careful, because if you emit too much stuff, there's a lot of things to sort and a lot of data to duplicate. So you got to be careful on minimizing the amount of data you emit into these tiles. So that'll be some optimization we'll be making after this tile binning thing. So yeah, we got to. So ultimately, we want to have this shader is not going to be actually generalized. This is going to be done per thing you want to tile bin. So we'll have one for like UI elements, which will generate. Essentially, we want it to emit, which is the range of tiles, and what is the sort of thing you want to render. So we'll say that is an ellipsoid. So we'll make this shader sort of emit a single thing, and then we'll make another shader which will just basically duplicate that item. And that one will be generalized. So I think there'll be a few of them actually to handle different numbers. So if you've got a very big ellipsoid on the screen, that's going to want to duplicate it many times. It's going to probably want a slightly different algorithm. Whereas if you want one which spans only a few tiles, you want a different algorithm, because it would just work better that way. So yeah, I think what we should do is break this into those different shaders, and then we'll add more of them later on. We'll add more of them later on after we've done the sort of generalized tile binning thing. Yeah, so after the shaders ran, we call that sort function. Now they're all sorted, but now you have to figure out where do those many different sized arrays for each tile start and end, and that's what the next shader does. So we memset this array where it's got the ranges, then we find the starts and the ends actually. So this is all going to be generalized code shared like in just some function. It's a bit like this sort function, right, that we've got for which implements the AMD parallel sort. So I've just ported that to this code base. It would be something like this where we just call it, and it would just launch a bunch of different compute shaders. Like this one just does the FFX parallel sort stuff, right? It just launches a bunch of compute shaders. We're just going to be doing our own. It's something like that, right? It's just utility to help bin elements into screen tiles. So after we found all the ranges, then we can utilize the these sorted ellipsoids and the ranges, and then do our ray tracer. So this is where, yeah, this is where we actually use it. So this won't be generalized. So all this stuff here, basically, there will be more shaders that will run, will be generalized. So that'll be pretty sweet. So let's split the shader up, and we should probably find out some nice names too for them. But let's start with the splitting first. So we'll call it, so this will be called, so this one you want to say tile bin, you could say splat, because splat is typically like, say if you have like a vector and you want to fill it with like a single scalar, that is known as like splatting. But it's kind of like, it's duplication, but you're also modifying things. So you're modifying the sort key a bit, because imagine you're doing this sort of for loop and you're going over all of those tiles. You're essentially just, this shader gets given a range of tiles, so a tile range, which we'll fill in. So it's just two XY positions. And then you get given this sort of thing you want to bin. So I guess you can call it the I don't want to call it an entry. Maybe I should. But it's the, you could call it the binned object. Just to be a little bit more descriptive, I guess, or binned entry, I don't know. So this is what the shader above will output, and then this shader below will take that tile range, duplicate this binned entry, so it kind of splats it. But the payload gets this sort of binned object instead of which is this ellipsoid index. And then the sort key will get the current tile index and the depth of, oh right, we might want another thing to go in there as well. Yeah, you probably want a depth in there because you want to sort them front to back. So you want another value which represents the depth. And then you also need to know, as part of calling this general tile binner, how many bits does the depth get? And how many bits does the tile index get? Because you could configure that yourself. Yeah. Right. But how's everyone doing? Welcome, welcome. Hope everyone's having a good weekend. Right. So I think let's make those. Yeah, let's make this thing. I guess we can use my new encoder system, because it's always good just using that some more. So we're going to encoder shared. We won't get any syntax highlighting because Visual Studio, I can't figure out how to do it. Every time I search something on Google, it's like Visual Studio Code, and I just don't know how to. Wait, why are my lights being lights? Boom. Hey Sigma, how are you doing? Hey, they're only having fun? Right, let me turn off the big boy light. What you guys been up to? Yesterday, I went shopping, got some Christmas presents for people, and then I came home, and then I ripped apart my PC while I was downstairs with my wife watching TV, and was trying to pull out all these NVMe drives, and it took longer than I hoped. And then I installed Arch Linux. So on this computer right now, I have Arch and KDE on the other M.2 drive, and I'm just in the process of resetting it back up. So I think this might be the last stream on Windows for a while, which is great. I can get back onto something more pleasant to use. But yeah, I might go try and install a tiled desktop environment. So, or a tiled window manager, and yeah, use Wayland as well. I haven't used Wayland for a while, so I'm gonna give it a test. Hopefully everything goes good. So I'll gradually be setting that up over the weeks. Get back on Linux again, which would be great. Start my day, gonna work out and run errands. Awesome. Yeah, workouts are always a good thing to do. Yeah, I just started getting back into my routine again because I took 2 weeks off. Because I made my knee wobble again. So I've just been letting that recover and stuff. But yeah, one of those things. Tile bin element. So should I call it element? Or entry, but then entries, I don't know. You got to stick a general word in there somewhere. But it's like this sort of thing, right? We've got this sort of like tile range. So we need like, I reckon, right, we can, if we make each coordinate be restricted to 256, so a single byte, in tile space, it means you can use a whole U32 to represent a range, which would be pretty cool. So you could, we can use like 8 bits per, because it's on GPU, right? I can't use a U8. We can say, I think I've added this support now. I can just do that. Then I can say tile start X, start Y, and then end X, end Y. Thing is, it's got to be inclusive, because if not, it will go out of bounds with the integer. I'm usually an exclusive guy, unless you say width, tile or grid dims. Wait, how are we gonna say it? How many tiles you span? Or is it count? But then the problem is that'll have to be, yeah, we'll just do inclusive end. Works. Right, so I'll take up a single E32, which would be nice. Save that bandwidth. So we need to now somehow have a binned object and a depth. So a depth needs to be passed in, and then the actual object you want to bin. We'll call them bin objects. Bin objects, there you go. So yeah, my problem is that depth is taking up a lot of space. Do we need anything else to... Right, I think that's everything we need. So that's 12 bytes entry. I don't think you can get any better than that, to be honest, so let's just accept that. So there's our... so this... Let's do a bit of code gen. Hang on a minute. Yeah, so don't finish the resting period. Don't want to give myself an overuse injury. Yeah, it's difficult with those things because before you have an injury, you have like no idea what it's like to get one. So yeah, but then when you get one, you're just like, oh damn it. This is what it's like. Yeah, you don't know where the boundary is, but I guess you get kind of signs of it if you're aware of your body, like, and I guess you get that as you build up that. If you take it slowly, more sensible with it. Oh, for crying out loud, is it really dependent on that? Well, that's what you get for having unnecessary dependencies and right, so that won't build because that won't build. Alright, let's get it building again. It was... Yes, let's get rid of those from global space. And let's give that a different name. Build that one. Cool. Right. So we got a new structure. So it should be generated somewhere. There you go. There's 12 bytes. So all these macros help us pack it and stuff, but yeah, hopefully the compiler optimizes some of this. Also, that looks a bit dodgy. So we'll see if we have to drop in and fix this, because I think I broke it some more. Maybe I didn't. Yeah, I think I broke it. That looks a bit wrong. So time for the value you pass in. Why do you take 0? What was the reason for the takeaway? Then you meant to and the bits out where it's at. Yeah, something wrong with that. Let's look into that. Encoder generations here. Okay, so for the macro defines. Right, bit field load. It's the store, isn't it? Yeah, so what did I do wrong here? No, it's a different one. Not this one. This one. So where's the... I must have added support for something else and then broke it. Classic. So this is always... Oh yeah, what's that takeaway? The clamp. Clamp take what? PN. Ah, that's the min value. That's fine. Right, so this one, why is it always 0? That's the question. So, what is mask again? Mask is the number of bits. So 8 bits. Right, so we're putting all those 8 bits on. Then we're saying, right, shift to your destination. Why is there a not there? That's the weird thing. Then and it with a word mask. What's the word mask? Right, so bit of a word. So the words is 32. That's just all 32 bits on. Why are you knotting? That seems like it just cancels it out, to be honest. I think I accidentally put that in. I don't know. Did this refresh? I think so. Right, clearly that wasn't the fix. Oh, it's done here later on, is that right? No. Then if you have multiple. They've both got the problem though. Or the not there, so why would you not it? Oh no, you would not, because you're saying, yeah, keep all the other bits but me. Right. Yeah. What does that look like? Can't run in the debug because I didn't set it up. Whoopsie. Yeah, that's what I'm expecting. What's word mask? Why is it 0? $32, yeah? Alright, well, one shift left. Yeah, so obviously that will go past 32, right? But then instead of 0, then you take 1. It should fold back around. Isn't that right? I don't know. Thought it would be right. Clearly not. Is that just different behavior? Depending on the... Because if I didn't do that, take 1. Right. So if I was to print out that bit count thing again next to the number. Yeah, so in one shift left 32. How are you left with 1? Is that just something that differs between... Not Vim? Ah, yeah, I did Vim. So basically, I think I updated my Neo Vim. Yeah, so I went from Vim, and then I was like, well, let's see what the cool kids are raving about. So I went to Neo Vim. Then I just updated something, and then the packages failed, and I was like, ah. I updated something in some of my plugins and something like that, and it just broke it, and I couldn't be able to go and fix it. Very complicated config. So I switched to Helix because the configs were just nice and simple, and out of the box it's just set up with stuff. And I find it quite a good experience. It's comparable, but it's easier to set up. It has its own little problems, different to any of them, but it does solve different some of the problems that NeoVim has. And I do quite like it. So I'm actually going to be going back to that when I get back on Linux. But I got a new GPU because I was just fed up of these GPU crashes. And so yeah, now I'm on Windows because Windows was the only operating system which dealt with a GPU swap correctly for some reason. But I mean, I've got a Arch Linux install on the other drive now. And I'll be going back to the hopefully next stream. Just got to go ahead and finish the setup because I'm using Wayland now and my OBS is not quite set up, and I've got to test if the game runs on Wayland. Only having fun. Just put in a 1070 video card in in a not so old PC, but power supply 550 watts doesn't support the extra demand. Ah, damn it. Yeah. Hmm. Yeah, maybe you do need another one. I didn't. Oh, yeah, I don't know what the. Yeah. Have you got many like hard drives hooked up or anything like that? How much? Maybe see how much power they take up and see if you can unplug some of them and to sort of see if it works without it. Um. Yeah. See how that goes. Or I guess you just have to get another power supply. Right. I could have swore right. Your 32-bit number. Or is it because it's? Is it because it's signed or something like this? No, maybe. No, that's only shift right. Yeah, so your 32-bit number, you do sort of 1, shift left by 32. Why would that leave you with a 1 in... Let's see what it does at compile time. But yeah, I do see that... Yeah, then you take 1, puts all bits on, right? Even if you 0 take 1, puts all bits on, right? So that's the logic I'm expecting to see, but yeah, I don't know if it's only on Windows or not. Oh, for crying out loud, why are you complaining now? And these dependencies. Right, so I'll build that, and this will build. Yeah, I kind of just needed to include a whole bunch of stuff in my encoder gen because I started using my game. Yeah, I know, but do it. I want to see what you do. But yeah, we saw what it does. It produces 1. I wonder if there's like some undefined behavior or something that's going on, but it's not even got optimization. Has it got optimizations on? What do I do? No, there's no optimizations. C, shift left, past. Let's just make sure. Maybe I gotta put a U in there. Let's try a U. Right, so the middle number is going to be the number of bits. Number of bits, so you do 1 shift left, number of bits, you get a 1. When is that how it works? I could just make it U64 and just move on, but I'm super confused. So, okay, let's just make this. Right, so make this a U64. Shift left bar 1, take 1. Then we cast the whole damn thing into U32. Even before we take the 1. Let's see what happens. Oh, no. I've got to rerun the thing again. Alright, it's still ran. That's good. Alright. Ran out, it worked. Why? So that's what I want. I want all the bits to be on. So past integer width. What is that? Why is it different on the platforms? Because I'm sure. Oh, did you it still be an int? What about casting -1 to an unsigned int? Yeah, maybe it's, but it should have integer promotion maybe? Anyway, it shouldn't matter because shift left sign. I'll try it. Shift left is same for sign and unsign, instruction wise, right? No, still the same problem. Gets a bunch of zeros. And this gets a 1 in it. But bananas. No, I'm not Greek. Well, I don't know how far back where things come from. Parents are both from UK. Parents both from UK. So I don't know how far back it goes. But yeah, I don't understand why. Like if I open up in Godbolt, still gonna, and then I say right, do a bit of C. Just use Clang or just use GCC, right? So if I was to say int main, I guess I can just void that. So if we just print so we'll have some value. I can't do it without those. How can I get the value 32 without the compiler knowing? How many values I've got from argc? No, don't do this. Alright, let's give that a go. How many we got? 1. Great. Times 32. There's my attack. Right, unsigned. In. This is value 32. And the compiler won't know a thing. So if I did 1 shift left, what do you give me? 1. Why? So if I did 31, You're going to give me... It's probably treating it like a signed in, isn't it? Something like this. Right. I'm just going to not bother trying to understand what's going on and just solve the problem and move on because this is not what I want to be tackling today. But maybe I can figure out in the future what the problem is. But I don't know. Right, so what we do is one shift left and compute that word mask. Yeah, I thought when you shift bits out, it gets shifted out. So if we shifted it 33, it's not going to go to 2, is it? It does. Is it wrapping? It's doing a... What is that called? It's a rotate. Is it implemented using a rotate or something? Wait. Hey Lupe, how you doing? Type of welcome. Welcome, sirs. How are you in this cold evening? I'm doing quite well, thank you. I'm just puzzled by... I thought I knew C programming, but apparently I don't. I don't understand. I'm just puzzled. But yeah, I'm doing good. I've got Arch. I installed Arch Linux last night, and I'm getting back on Linux very soon. Yeah, so you made it a U64 basically, right? And then what? Is that all bits on? Find out. I think it is. Yeah. Yeah, I know what -1 means, but I don't know what you're trying to say. I'm trying to say what happens when you shift 1 past the integer, and it seems like it's wrapping. So I'm trying to understand, like, I cannot see the shift left op. Yeah, it seems like C does shift left, rotate. Yeah, it's meant to shift. Yeah, yeah, but I don't. I want it to be all bits 1 based on a bit of maths, not like hard coded bits of 1. I know how to get bits of 1. I can just write it in. the The problem is I'm trying to say, right, given a certain number of bits, give me all of the bits on. So I shift it left by that many number of bits, and I take away 1. Right, but if I shift it past the integer, it should still work for a 32-bit number of bits. But it ends up rotating the 1, which is confusing. I never thought, oh, why is it rotating? It is literally rotating. Look, I did 33 and I got 2. I did 32 and I got 1. I did 34. Like, it's literally rotating. Maybe say, I can't see the actual thing. What is SAL? Shift bits beyond the destination operand boundary are first shifted into the CF flag and then discarded at the end of the shift operation. So why is it rotating? Yeah, but I don't want to make it rotate. I want it not rotate. Like, why is my shift left rotating? I've never seen this before. I don't understand. It shouldn't rotate. This instruction even says so. Shifts the bits left, copies carry flag to the least significant bits. Right, so it does is it's got the RCL. Where's the RCL at? I can't see it. It shouldn't rotate. Alright, that's a good idea. So we shift right 64. Yeah, it goes around again. 65? Yeah, keeps going. There's two cells. Okay. Anyway, I'm just gonna solve problems today. I generally don't understand why. Anyway, so we're gonna cast that to U64. And then just cast that back to U32. I have no idea why. It's just bananas to me. Such thing happens. I could probably read the assembly a bit more and understand it, but I cannot be bothered to do that today. So let's move on. Generate. Go back to here. There you go. It's anding out the two bits where this is supposed to go, and then it alls them in. I swear that was working like that before. Does it rotate if it is? I don't know. I didn't try a right shift because a right shift can be different if it's signed. But yeah, that is a good point. Oh yeah, one I wasn't using it. So if we shift right by 30, even just by 1. Right, well 0. Still got 0. Like why is it rotating? And this is GCC and Clang is also doing it on Windows. So I'm using Clang. And I don't understand. Yeah, but why can't? Yeah. Okay, so Lupo, this is what I'm doing, right? I'm shifting left by 32, and my 1 goes out of existence, right? It goes off the end, and it's wrapping round to the beginning again. So that's the behavior I want, right? I want it to go off the end, so I can take away 1, and then all of the bits come on, and so I have a mask. But yeah, it doesn't. Is it undefined behavior? I don't know. Anyway, I want to carry on. If someone can figure that out, I'd be interested to know. But I'm not going to carry on and do it myself because I've got other things to do today. I think yeah, I'll do that for you. Share. Do a short link. Yeah, that's cool. I'm curious too, and I appreciate you willing to give it a go. Right, so we've got this tar bend object thing finally. We're filling it in. So call it bin obj. So say bin obj dot I'm going to say dot graphics tile bins. This is our code generative functions. We're to set the start x, which would be equal to tile coordinates dot min and dot y. Yo. Yeah, so if this value goes above 256, it's just going to get rid of some. Oh, wait a minute. Yeah. So these end indices, they're actually going to be inclusive. Not a fan of inclusive stuff, but the only way I can do it. So we'll say these are inclusive. Cool. So we've set those fields in there. So it's just crammed down into a single U32. And then we set the depth. So the depth is this depth fixed point 8 by 8. And then we have this, we have the object that we want to bin. So that's the ellipsoid index. That'll go into the object. So this is what we're going to be emitting into the buffer. So we just got to find yeah. So I think, yeah, so this shader as input is going to take an array of yeah, we're not doing these sort things anymore. Yeah, we'll copy that. Alrighty, yeah, we'll put like an S in there or something. I don't know. We'll sort that one out a bit. So this is just going to be the actual objects, bin objects. We'll emit those, and this is how many objects. So how do we know? There'll be some global, I think. So there's 32 threads here. Maybe we can up this number and do 256. It's usually a good number to use. Gotta be careful with these waves. So in the local wave, which is 32 threads, they run in lockstep. We would like to produce the number of so yeah, we're going to be doing an atomic add, and we're not doing an atomic add per thread. It's just wasteful. So we want to take all of the wave objects count. So that's just a wave prefix sum of 1. So every active thread in a wave will just add 1, and that'll give us the number of active threads. Then we take we want to go if wave is first, thread is first. So the first thread within a wave which is still active. This one is going to be the guy, which atomically adds 2. This will be the so we'll call, what do we call them? The bin objects. So tile bin. What object in the end? Oh yeah, it's right there. Bin objects. Count. And we're just gonna take this object's count, do the increment. Wait, no, sorry, not prefix sum. wave insert index. Yeah, that'll be prefix sum. So every thread will get a different, every thread within the wave get a different number. Then we do a sum, and that'll get us the total objects count. Right. The one, yeah. So this one does the increment. So this all 32 add 32 to this number. And this is the base. This is what's known as the base. You've got the base insert index. So you have your base insert index. Just initialize that. Ah, no, don't bother. Yeah. Then you do after this, so all the other threads in the wave be inactive, so they don't get this value set. So you have to say wave read lane or read thread. We're going to read a E32 value or BGPR from. So we're reading this register, whatever the value this register is in, and we're saying from thread. Wait, how do we do it again? Wait, or we do a min. Yeah, I could do a read lane, but I don't know what lane it is. I did it. That's the problem. We can set it all to max. And then we just do a min. But there must be a better way to get a read to go. That'll do for now. So we might be able to improve this further and use a bit of LDS memory to do another min across, or do another do this all in one thread group. But then you'd have to stall the other threads, so it might not be worth it. I don't know. This will be alright. Then we can get this base index and then start inserting stuff. So we go over yeah, then everything. So we probably want to do like a BC bin objects. We get the actual insert index. Insert index equals base insert index plus wave insert index. So this would be an offset within the range that it's allocated basically in an array. And plot that in there like so. Then we can just replace all of these with this. And that'll definitely compile to some pointer thing. I don't know. Or we could have put it in an object and just copied the whole object. I don't know. Right. Cool. So that's all this shader is going to do. It's going to emit these tile bin objects things. And then there'll be another shader. Delete this, I think. Which, so we've got to figure out a name for it. This one is going to be called tile bin. I could call it splat objects. That splats the objects. And we'll have different sizes because if you have one object which splats into 4 tiles, it needs a different shader than one which splats into hundreds of tiles, because the way the threads do the splatting will just be, and the way you minimize the amount of inactive lanes in a wave will just need to be the code just needs to be different, which we'll see a bit later today, hopefully, if we don't get another one of those silly bugs. Show me main.c. I don't see the point in that. Hey there, soy. Shift and left without masking it behind a variable results in a shift count overflow warning, indicating undefined behavior, whereas temporarily casting the... Okay. Right. So it's okay, so it falls into undefined behavior category. Okay. I thought it could have been that, but yeah. Right. That's a shame. Because it's not how the numbers work. Like ideally, but I guess the hardware can do something different then. Yeah, it's just a bit weird, right? Anyway, I guess we've all learned something new today. Yeah, it is, isn't it? It's an unsigned int as well. I thought those guys had superpowers in the C standard, but obviously not. Splat objects. So there'll be different versions of this same shader, but we'll just write the stupid one. This one will be the one which we use for the small stuff, I think. So this is going to get, let's just go to the, get the inputs ready. This one. No, this one, yeah. So this one's going to emit into those sort key arrays and the payloads. We don't need to count, I think it's going to be launched indirectly. It's going to be ellipsoids, bin objects. Yeah, so it gets the bin objects in as input. This will be the read-only buffer. And it's going to output into these sort key arrays. Right. This is where the magic begins. So, right, so we get our object index. And all objects. Objects, object index, and we get this super lovely bin object. Read that whole boy out. OBJ, obj as some people like to call it. So what obj is going to be doing, let's delete all this, is essentially making these. So we'll be like S32 times 2. Graphics. So we're going to unpack the tile bin object start x from obj, and we're going to unpack these lovely long names. We'll unpack this 1, 2, and then this is max. So we've got to add 1 because it's inclusive at this point. So we add 1. If not, we run out of bits if we don't make it inclusive in the packing code. Cool. So there's our min-max range, tile ranges. I could have called it tile chord, then it'll be longer. Yeah, and then I can call it min and stuff. Tile chord min-x, and then they're all the same length. It'd be quite nice. Min-max, and then we know it's inclusive because max means the maximum. Yeah, min-max sounds inclusive. Perfect. I don't need to self-documentation. There we go. Right, that was good. Just made it even longer though, but yeah, there we go. Probably could have dropped the coordinate thing from it, but yeah, they're already inclusive. I just saved myself a bug. Recompile that. Neat. I think you can do something special with the multi-cursor. Oh no, you can't. There we go. Do multi-cursors now. Cool. Right, so there's your min maxes. So we need to know like what is the tile dim, or do we? Oh, what are you doing? Oh, you wouldn't need any of this. Alright, now we work out the number of tiles, and actually, hang on a minute. Alright, maybe I got this all wrong. So if we've got like, if our tile size is 16 and this lands, right, this will go up to, yeah, max should be inclusive. We should round up and take 1. Yeah, we want to make it inclusive. But yeah, it's max, it's meant to be inclusive. So you round up. Yeah, so I'll make it like 16 or whatever. So this tile dim has to be, we have to set the tile bin tile dim at some point. There'll have to be another, right, so make a new sort of one specific, like the way for the sort stuff, we'll have one specifically for tile bin. So tile bin, or maybe put it below the sort. So the first one, tile bin, tile dim. So the dimensions of a tile across one axis. Setting that. There'll be the grid dims. This would probably, would it be set on, or we'll have to set it on GPU. Maybe we'll have to make a shader which will sort of initialize it. But yeah, it would have to be, oh wait, it could just be passed up into this thing as some constants. So maybe we'll make these, so whenever we need it, we'll pass in some kind of like tile. Yeah, so I think we'll put them here. Graphics tile bin specification, I guess. Right, so we'll let's sort it out. So yeah, the size, what is the size of the tile, so we can automate some of that. And dims, we'll probably pass it in via my value into the scanner. So we'll pass in some kind of like spec, the bin spec. Wait a minute. This is specifically for the no, you don't need this. Right, undo, undo, undo. That is fine. Right. So we don't need any of those, I don't think. We'll see. Maybe we will. Right, so that shader looks alright. Split objects. We'll get them in max. Gotta be careful of the for loop now. Gotta be an inclusive loop. Cool. So you gotta add 1 here though. Sneaky, sneaky. So you do a subtract, add 1. You know, I could have just added 1 onto those there, but yeah, you get the number of tiles. So this is the sort entries thing. So tile bin objects count. OBJ. Yeah, obj. Obj. Put it to obj. Put it to obj. Where's my... I don't have you around. You don't exist. Ew. Exist. Right, so there's some objects we want to tile bin, and this will be the number of sort entries count. So we will now this whole job is about duplicating objects. So it's gonna add based on number of tiles, get the insert index, do this terrible n times n complexity loop, and alright, I think we will need it. We at least need a grid dims x, but we could get that. Oh, there's a tile dim as well, don't you do this? Wait. Yeah, this is for debugging. We don't care about you. Right, so we need a grid dims passed into this shader. We can do that from CPU side because we know. And this would be some more debugging. Get rid of that. So pass another E32. This would be the number of tile grid width. So how big is the that just flattens it out. Although, do we even need it? Because why flatten it out when you could just take the coordinate and just stuff it in the top bits anyway? So what I should be doing is, so these are, we're going to cram this into a tile coord integer. Let's say the y goes in the, yeah, let's just say the y goes in the, wait, what am I doing? 16. Oh, it's 8, isn't it? Yeah. Then in total we, these are from 0 to 250, 255 inclusively. Then that'll just go in there like that. Shift left 16. And then a low bit. So what we might have to do is say, how many bits do you want to use in the sort key? Your depth. That might be a thing. So depth is going to come from object. So we'll pre-extract this. Depth equals graphics tile bin object. Is that even a thing? Oh no, it's just object to object. Yeah, can't get better naming than that. I'll go there like that. So we could and it and save the errors. Cool, sort key goes in, and then in goes our lovely obj.object. Wait, this meant to be object.depth, not object.object. What am I doing? Cool. Right. Right, so that's our splat function now. So this is generalized. It's not got anything ellipsoidy in it. So it means that we could share this. So we'll be running more optimized versions of this function because right now, say if you span the whole screen, one thread is going to be going over the whole screen worth of tiles, which we saw could be 124,000 entries, which is just insane for a 4K screen if you have such small tiles. So we don't really want to be So your tiles should probably be bigger to not cause something like this, or you should ensure that objects never get the size of a full screen if you're doing tiles that small. Yeah. So we're going to be writing shaders though to probably help handle these cases. Probably not solve for it though, because I don't think we're going to encounter that problem too much. But yeah. So, right. This is good. Right, I'm just going to take a quick break, and then we'll come back. We'll, I think we'll get renaming these shaders. We'll move them to another section for like the generalized tile bin ones. Get the current ellipsoid renderer using that, and then we'll do the optimizations. What is this JavaScript? I know, right? Sometimes when you write code that's general, it's hard to name things. Everything just becomes general. Right, I'll be right back. Let's enjoy the tunes. See you soon. Right, welcome back, everybody. So, let's get on with this good old rename. So this one is all about finding ranges, not finding starts. So after we've omitted them and then done the sorting, we need tile bin, find ranges. So after we've splatted entries out into the sort keys arrays and then sorted them, we just got a bunch of arrays of different sizes, but we don't know where they start or end. This finds that all. Yeah, so this is the ranges buffer. This is the yeah, let's call it that. Ranges. So this one find ranges. Welcome, welcome, welcome. Thank you, sir. Yeah, so we just omit the count here because reasons, but yeah, so we'll take this one. And also, where is that ellipsoid sort? I gotta be careful. Yeah. So next index. And also we need to probably just set up where it will. We might need to set up shader which will sort of clear that. Clear this. We'll do that in just a second. So all this does. Oh, this is the setup function. Yes. This one sets it up. Sets up the next shader call. Put some indirect stuff because you don't know the number of entries. If you have entries, populate the find. This is in the indirect buffer. I've only got one indirect buffer. So I can have one flag, one usage flag. Yeah, so my usage flags are hard coded in my Vulkan backend. And then for this indirect buffer, it's got the indirect flag on it. This is a special case. So bin find ranges dispatch args. Cool. Yeah, so that's gonna set those up. So if we haven't got any entries, we put a 0 in there, so it shouldn't launch anything. Well, it might. It still might, I guess. Then if we have something, why do we do take one? What's the problem with that? There's a reason why you do a take one. You only have one entry. Right, so if you've got one entry, you should round up. The divided round up. They'll put one in there. Yeah. Cool. So let's just say it's hard-coded to 16 for now. If we want to change it, we can change it. Well, no, you can't do different number of bits without changing how this gets put together, this coordinate here. We'll leave it. So it's not configurable. So you fish out the first sort key. You find the first tile start index. The first tile that has entries, you get its. You look at the first one. Oh, it's for Wait, do you want to call it a tile? Ah, shoot. It needs to be it needs to be a tile index for it to work. So we need a way to where either it stays a tile index or we put it in. Alright, let's put that grid width back in here. Tile grid width. So y times width plus x. It's just flattened out. We're still sticking the high bits. Cool. Gotta remember to set that. Yeah, so we extract out the tile index. We set the range for that tile to 0. Sorry, yeah. So this is the first tile in that array of entries. And then the last tile. We fish out the last entry. We fish out its tile that it's in. Right, sorted the tiles from low to high. So the highest tile in, I think it's in row major order. The highest tile, the highest indexed tile, which has some entries, it will then set the end index up. Cool. Then after this setup shader is ran, it's going to run the actual one which finds the ranges. And this one is going to not ellipsoids anymore. So it's going to go over pairs. Oh no, you do take one. I know why you do take one now. Crap. Then it's going to launch 0. So because you're checking pairs of values, the first one is going to check. Oh, do you need at least 2 entries for this algorithm to work? Otherwise, it's not going to. Yeah, I don't think it will work when you only have 1 entry, but I don't think that's a problem. It might be an issue actually. If you're checking pairs in an array, so you'll go over the first dispatch will do 0, 1, the next one will do 1, 2, and so on. Right, 2, 3. Well, if you have only an array of 0, 1, 2, and 3, you only need to launch 3 times to cover all pairs, right, and not 4 times. So that's why there's a take 1. So basically, we want to say if there's greater than 1, you do this. Right, so technically it's like threads count. So the threads count is actually this one here. And I'll put a comment which says take -1 as we check pairs of entries. As each thread checks pairs of entries and not a single entry, right? So then that means we need to handle the one case, and the one case. Wait, is the one case already handled here? The one case is already handled there. Excellent. So that'll work perfectly. So we'll just do if greater than 0, or if not 0. Nice. Okay, so that does work. Excellent. So yeah, if it goes out of bounds, then stop. Neat. Yep. Tile indices. Right, it's just called ranges now. Nice. So that's nice and generalized. We just got to move it to the a new code section, because if not, it's just all a bit messy. So we've got a sort of parallel sort section. What I would like to do is take code like these three and stick it somewhere that's just sort of, that's BVH. Maybe we'll stick it above the BVH. That was, oh, it's shaders. I don't know what's going on with that section actually. Raw 2D, there we go. So it's parallel sort, nice. We'll stick it here. So this is a section specifically just for tile binning, and anything can use it. We'll use it for UI. Eventually we'll port the UI stuff to it. So tile binning. And that's utility shaders. So is this in the BVH code? What a wally. Got some things in the wrong place. Put a bunch of right, what's this section up here? Right, there we go. So stick it here. This is tile binning stuff. We'll nick this. Drop it in here. So these are just the push constants. They got uploaded to each shader. And then there's other ray tracing ones. So let's get those out of the BVH because that's just silly. Or no, like that. Hey, Wajilla. How you doing, sir? How have you been? What's your weekend been like? What have you been doing? Neat. So there was something that I wanted to do, and that is when we do this tile bin thing now, we need to make sure that some of these are initialized to something sensible. It's this one here, I think. It's only this one. So we might need to call it like a setup. We might need to have a setup function that gets called. Do we? Yeah, because we add it here. So this one will be called setup. And all it's going to do is just, guess I can get away with no push constants, which doesn't really optimize anything. It just means I don't have to make another type. We're just gonna, I've already got the variable here actually. We're just gonna, one thread please. We're just gonna write to this thing and put a 0 in there, because the next shader is gonna atomically add to it. Where the hell it is. There we go. It's also got a 0. Where's the other one? There's another one. Bin objects, which is the one. Oh shoot, that means the this has got to be called we'll have two functions then. One which is called before the tile binning, one which is called yeah, there's got to be a different part. One was called at the beginning, then the user calls their shader, which figures out which things they want to actually bin, which objects they want to bin, and then we do another one which actually does the whole splatting of objects and then sorting, and then figuring out the ranges after it's been sorted. Yeah. So I guess we'll get those functions all hooked up now. So we'll take this lovely section header, and inside graphics internal header, we are we'll put it here. Yes, where's the GFX sort? There we go. So this has got a bit of sort here. We shall do our own. Are you telling me that the drawer doesn't have its own section? There we go. So inside here we'll put our lovely graphics tile bin. So we'll have something called, we might be able to get away with a start and end. They'll probably take parameters. So a start and an end. In between, you emit your objects into a certain array. Yeah, so this is where they'll go. Gonna be amazing. All right. So if we take these boys and girls, well, let me, right, so I want to, let's write them in here so we can get back. Tile bin start. Do your thing here. I gotta figure out a better name for that. And we shall. We'll take these. So, all we're doing, we're not doing a sort just yet. We've got to do a, I guess it's, right, bin ellipsoid sort keys. Right, so these arrays will be changed. Yeah, we'll get back to that. So, we'll call them tile bin sort keys. And then we'll have a tile bin payload, sort payload. So the payload is just an additional U32 that gets sorted alongside the sort key. The sort key defines how the things get sorted, and the payload is just additional data to help you actually do something, because a U64 is a lot more powerful than a U32. So we're definitely going to, yeah. So the plate. So this is done indirectly. So the number of entries is it's 1. Tile bin sort entries count. So that's going to do an indirect. So it's a shader on the GPU is going to fill this in, and that's a shader which we'll set off in a second. This is going to be the tile bin ranges buffer. And on the flu of the weekend? Oh no. On the mend today though. Cool. Yeah, sod's law, right? Just as the work week begins. But I guess, yeah. Days of rest at the weekend anyway, typically for me. Yeah, I'm glad you're on the way out. Also, it's good you got the cold before Christmas, you know, so you're not the person who's ill on Christmas Day, trying to keep away from everybody. Yeah, how's your projects coming along? You been working much on your engine? Right, so this one's gonna tile bin, find me some ranges, and then tile bin sort keys buffer, boom. Yeah, it's probably gonna write out to the. No, you are not. Oh yeah, this is the setup one. Yeah, so it's gonna do find ranges sub. This will do the setup, and then we'll do it again. But this one does the actual find start with the indirect arguments. Oh no, we sorted that one out, wasn't it? Here it is. Neat. So that's in the indirect arg buffer. So we don't have to say which buffer the indirect args come from because they're all just from one buffer, which is quite nice. So the GPU API for this project is designed around that. So the sort keys, and we need the ranges buffer. So read write ranges. That's a good point. Just copy those two fields over, but there we go. And we read only on the global buffer, I think. Anything else? No. Right. So those look like they're in a good place. Let's copy this one here. And I want to launch a new shader. This one is the one which is the splatting. Now the splatting is going to be broken up into a few of them, so we can optimize it. But that comes later. Just get this new one up and running. So these are the things we need to fill in here. So this tile bin object, I haven't done it yet. So this would be the objects buffer. We've got to make that buffer objects. We're going to write out. Oh, we're going to read these in. So this is the one that the user of this tile bin is going to fill in, and we're going to use. We then need to have the sort keys and the payloads. Yeah, I've already got that there, right? Of course. Payloads. Payloads. Nice. And we also need another one, which is the tile grid width. So we probably want that passed in as a parameter to the function. So given the screen, how many tiles have you got across the width? And voila, that looks like we're in there. Do we touch global memory? Splat objects. And we're doing an indirect of what? We do need to indirect, which means we need a setup function. Yeah, we do, don't we? So, yeah, so that's two questions there. So the first one was splat objects. Do we touch global memory? We do. We read write to it. So put that there. Bit of sync code. Dangerous sync code. Right, seems alright. It's a bit of a read there. We've got that one, wasn't it? Free global, yep. Nice. I read from global. Good. So we need to make another one. The splat objects, which sets up setup. So this one is probably do something like this. Oh, I'll delete everything, didn't I? That's what I wanted to do. Yeah, well, I did some of the indirects. So there'll be like one of these sort of things for in split objects. Which will be filled in. So that will be filled into. So this one specifically has 32 threads in a thread group. So we're just going to do not this number though. There is another number. It's called objects count. Right. What's the number of objects that the user generated, or what's the number of objects that the user wants to be binned into screen tiles? So we just take those and then launch this silly slow shader, which will get optimized later on. Cool, so we need to call that one now, so we'll just copy paste. This one won't be indirect. It'll be something like this one. With a setup on the end. And then we don't want to access anything basically, so we'll just get rid of that and read write to the globals buffer. So it will sync still because it read writes to the global. Yeah, looking good. So this is in a good place. We still have to call this setup one here though. So let me just take that, plop that in there. We'll do a no push constant, so it's just zeroed memory. We'll rewrite to global memory, and it's called tile bin setup, and it just initializes a couple of globals to 0. Nice. So, where's all these lovely ellipsoid tile bin width things that exist? Yeah, I don't know if these are used anymore on the GPU. They are. Right. So I'll take this. I'm going to find where this is used, and then in here we're going to say X. Right. So all we've got to do now is change this function and then set up the new buffers, because we ended up creating a bunch of new buffers for the general tile binning thing. So we'll have to do some renames. Should be done with the GLTF model loading at the end of this stream. Nice. We'll see though. Awesome. Yeah, so better drop in any file, hopefully. Yeah, I think there will be a lot of edge cases to solve because it's an importer, not an exporter. But yeah, should be cool. Get prototyping quicker. Why do you use U32 instead of Unit 32? Because it's quicker. Basically, to type, it's just like U32, and then it takes up less width. Like when you read it, like there is 2 wins, right? Typically, the win that you want the most is it has the readability of the code improved. Now, readability comes down to certain assumptions that you have to make, or things you have to know, the context you have to know. And, you know, integers are basically very, yeah, they're used in every single problem, right? So when something is used a lot, you, like, in my opinion, have a duty to shorten it as much as possible. Um, so it's just those things. So integer type, you shorten to U32 or whatever. You really condense the code down a lot, and you can um, as long as you know that it just means anything U then a number is an int. Unsigned int, then it's much easier, and then that's a signed int, and it's a float. So yeah, it's typically the way I go about things. But yeah, it's in Rust as well. It's in Odin. I think it's in Jai. It's in the way things are going these days. Yeah. Yeah, and then like my vectors are U32 times 2, right? It's a bit weird, but when you have a whole sort of vector library, it does give you the ability to have all these different ones without doing some weird sort of like vec2 f32 f32 and then like maybe you just call it f for float and then u, and those are always 32, but then when you do a 16 one you do a 16, you know. Yeah, consistent. So yeah, it's quite nice. I think HLSL is like uint 3. That's a vector 3 uint. But when I read that, I'm like 3-bit uint, you know. But yeah, so there's a bit of context you have to know when you write HLSL code. U64T. Yes, it is it's a bit to type, isn't it? And then you'll do that underscore and rather not. I have written code with that in my compiler though, my C compiler, because I wanted to have it as a library which I've never really used. So I don't want to steal some defines from other people. Jai's kind of weird with it, but it's not too bad. There's a default int type which is by default 32-bit signed int, but can grow or shrink. And if you want a specific one, right? So I guess that one is for speed reasons. Like, what is the sort of fastest integer type, right? That you want to use, but you don't necessarily care about the width. Yeah. No, but in terms of like the fastest int to do operations on, I think, if you have just a bunch of 32-bit ints on 64-bit, I think the 32-bit int is gonna overall do better, because the 64-bit int, it will take up more memory, and it's good enough typically for most problems. By grow shrink, I mean they can dynamically grow or shrink by any type. Inference. Right, sorry, I thought you meant depending on the platform you target. Right. Okay. Yeah, it's just like an implicit int thing. Implicitly typed int. Right. Right, but it is a 32-bit int, so it will still suffer from like overflowing it when you operate on it, but then if you give it to a typed thing, it will. Right, I see. Right. Yeah, so I want to change these buffer things. So these are gonna be reading from bin ellipsoid buffer. So this is eventually, right? This is gonna be the shader which goes over all the models. and then, or model instances, sorry, and then emits all of the ellipsoids. It does the occlusion culling and then emits the binned objects, right? So, um, yeah. So I think there's going to be one called tile bin objects ID. This is where this should be called bin objects. That is read right. And then we want a number of objects. Yeah, I guess it'll become indirect later. That's what I decided on. So yeah, I think we'll leave that one around, but it's definitely going to change in the future, which is fine. So calling this tile bin ellipsoids thing, I don't know if it's a good idea because it seems like it's part of that tile binning system. But again, we could probably change that in the future when we actually do the model thing. Yeah, I'm happy with that. See, again, this is probably not going to be called binned ellipsoid. We're going to be changing that as well in the future. Cool. Right. So let's go to this thing and sort out all these guys. So these are going to be called tile bin. That. It should probably go next to sort of sort one because they're kind of like a generalized set of buffers. And then when we initialize them again, these are going to be going sort guys. I sometimes use 8-bit ints, smaller counters, or loops, but honestly, I don't know there's a difference if it's crucible. Well, so the problem is we're using like a smaller int. That's not a native register sizes. I think there's on some architectures it starts masking it to obey the language rules. So technically it is going to be slightly slower, but you're not going to see it. So I think if you look at ARM, for instance, and then if you use like a U8 and you do some adding, I think you see it do a masking operation afterwards, I think. I don't know. That was when I looked at it a while ago. Might be a while. Yes, I think we'll call this the tile bin objects capacity. So maximum number of objects you can do is these. Guess we'll leave that in. That'd be nice. Do I need to support x64? I should mention that strongly typed, so the int type won't randomly change it given. Right, okay. No. Yeah, I thought Jai was actually on ARM, or it definitely will be on ARM because I think they'll want to port their game to like the iPad or something, right? Whatever that game's going to be called. It's gonna have to go to ARM, right? Because he put the the Witness on iPad, didn't he, at some point? But maybe he doesn't want to do that for his new game. Right, they're initialized. That's good. Right, I don't know what else is left. I guess we just press F5 and let the compiler tell us what we're not remembering. So my shader compiler failed because there's nothing called this. Oh, lowercase. Whoopsie. Let's go again. So this one is saying ellipsoid count. So splat objects. What are you saying? Yeah, how do we know the maximum? Well, that is in the globals. That one. Thank you very much. Next one. Signed in cannot possibly cast to be S32 times 2. Yeah, I forgot to put an S in that function call. There's an add S because we're adding with a scalar. Nice. Yeah, that comes from the bundled constants, aka push constants. I just put the word threads in there and not threads count. And then the ranges was not being used properly. Right, this one is saying what access expression is it? Oh, where are you? Ah, that's in frame initialize. So frame in it. I've already initialized the new variable name to 0, but yeah, it's different. Right, tile bin ellipse. Why is this? I just call it count these days. Objects count, right. Very bland. Right, we're compiling CPU code now. GPU code is all compiled. Buffer ID. Oh, did I not set this one up? Yeah, I gotta set that one up. Whoopsie. So, this one has got those lovely tile bin objects. 12 bytes per structure, and I couldn't get it any better. Graphics tile bin object. See how it goes. Alright, still some problems. Yes, it's called objects count now. Did a bit of a rename there. Well, somebody did not change the prototype. And out loud. Nice. And then, right, it's a couple more, or a few more rather. The ray tracer, right? So the ray tracer wants access to the payload still, so that'd be the tile bin sort payloads. Yep. Then this would be the ranges. So again, that's a tile bin ranges. Cool, so hopefully it still works. Hopefully we still get some rendering happening, and we should give it a bit of a test because there was some takeaway ones and things that we changed, which leads to possible off by one errors. Hey there, Zenerus. Actually, I saw you there earlier. Oh, fine. How's it going? Right, currently we've got 0 ellipsoids on the screen for some reason. They should be there, but it clears a bug. But there is code that runs. So you know, I guess it's a good sign. And also, you guys might have noticed that we've got some sort of indentation here. So if you look carefully, we've got Grouping. So they're called scopes. They're called profile scopes. I chucked these in. I think it was during my lunchtime on Friday and a bit of Saturday, I think. Yeah, that was it. So I chucked these into the code base. So I got ways of getting timestamps, putting scopes around them, and then they So we can have one. So in graphics sort, right? We got these sort of lovely scopes. You can push them and then pop them, and put them around commands, and then magically it will produce a tree of times rather than a linear list of times. So we can push on graphics tile bin. We'll see in action. And then we can do a good old pop. Now, you might want to name it, because you might want to put your own little name in there actually. So we'll put an HR, as well const it. Always famous last words. What is the name of this, please? Give me a name. And then... So yeah, this will be graphics, tile bin, ellipsoids. And then we simply just run that, and you'll see now in the profiler, there'll be even more. And I started actually working on a bit of a UI, because... For crying out loud, why didn't you work? Oh, it has worked. Alright, so there it is, tile bin ellipsoids, and it does a sort inside it, right? So that one, and it comes back again. Yeah, it does work. Perfect. Yeah, it does the tile bin stuff. Right, set up, bin the ellipsoids, splat, set up, then splat the objects, do the sort, and then do the mem set to U32 max for the ranges, set up the indirect args, then find all the ranges, then we're done finally with tile binning, then do the ray tracer, and so now we've got to figure out why, oh why. So the bin entries are apparently 0. So there's an indicator of what's going on. Why I've been printing out from the GPU, because I want to see what's going on. Readiness timer code. Yeah. So effectively, I can give you a quick little run through of that. So in the Vulkan backend, what you want to be doing is writing out these timestamps. So whenever we do a profile scope start, it calls straight into the backend, because I record straight into the command buffer in my thing. So whenever you're putting commands in, it's just going right into the command buffer. I don't have any sort of software command buffer. So whenever we do a start, it writes out a timestamp into the command buffer. And then whenever you do end, it writes out another timestamp. So, yeah. And whenever we do anything like a dispatch, it will do this profile scope thing. This is just little macros, so it will call start and then end at the end of the for loop. This just is a for loop. It calls push then pop, basically. So put the shader name in there, and then we did the dispatch. So this will end up basically put a timestamp before, timestamp after, and then obviously the outer scopes have their own timestamps as well. And then what the timestamp does is it uses a query pool. So you need to have like a couple of query pools, because you basically read back from the query pool. It's probably just a buffer under the hood, but they had to make yet another abstraction for it. Because it's Vulkan and it can work on anything. So yeah, we have a maximum number of timestamps. which is just the maximum number of commands times 2. You have 2 timestamps per scope and per command, basically, because a scope. Yeah. And then use the query pool. Yeah, then at the beginning of the frame, you check the query pool for 2 frames ago. And I basically just go over all the scopes and I just get all the timestamps and get their start and end index. Yeah, you'd have to sort of have a play about with the you just extract the timestamps out basically, and you can then use that for whatever you want. So I just debug print out into the terminal. But what I did get a chance to work on a little bit is do a bit of debug. Make a little profile UI, which just basically puts it at the bottom of the screen. It's still not finished yet, and it ends up crashing my GPU. So I think my UI system's tile binning code could be a bit wrong, or there's something to do with like a negative rectangle going on that I've got to investigate. They're my current suspicions. So yeah, that's currently in a work in progress state, but it will be very useful because I'm trying to track down some steady spikes that I'm getting, and I think it's, yeah, I don't know what's going on there. Maybe to use that new profiler. I'm much more familiar with OpenGL than Vulkan. Does timing compute dispatches actually wait for them, or does it? Right, yeah. So in Vulkan, so I've got 2 different timing modes. And I think this answers your question. Let me know if it doesn't. So it's 2 different profile modes. One is like, you can profile the whole frame. The other one is individual shaders. When you have the individual shaders mode on, what it's going to do is put a barrier in for every single command. Because if you did dispatch, these, in the command buffer, these will actually, in Vulkan, right, they will start in order, but they will overlap in terms of execution, especially if something like this one takes very long and this one takes very short. Wait. Yeah, it depends on how much the compute unit is being utilized and on the implementation of the hardware. So what we do is insert some barriers such that, so obviously make your code slow because you don't have any of this overlapping stuff going on. So when you have the profiling on, your code is your whole frame time is actually getting a bit slower. That's why I have a whole frame one which doesn't put these barriers in. And then I'm obviously putting timestamp here, timestamp there, timestamp, right? And this allows the timestamps to be written out when the dispatch actually finishes. The way the API works in Vulkan is that when you do that timestamp, VK command timestamp, right timestamp, yeah. Yeah, when you do the right timestamp, there's this sort of pipeline stage thing. So here what you're saying is when you say top of pipe bit, what you're saying is I think you're saying when the command processor of the command buffer reads this, processes this instruction, this command, take the timestamp. So I think it takes it like then and there. Or when it reads the next command. Yeah, I think it's when it reads the next command from the command processor. It's something like that. It's hard to remember all these things. And then when you do an end, you're saying bottom of pipe, which basically says like all the commands that come before me. You're saying something like when the commands before me have all finished, right? take the timestamp. So that's how it works under the hood, to the best of my knowledge. How's the stream still going? My thing's been a bit funny on my laptop. That refresh. Looks like it is. Awesome. Right, so where was we? So, oh yeah, there was a number was 0, and 0 is bad. So look for the word splat, that might help us. Yeah, so we print out 0 here, which means the number of sorted entries are 0. So this splat objects thing is not actually doing anything. So what I need to do is print out tiles count and just see what happens. Let's run that. Oh, my laptop keeps disconnecting. What a bugger. Right. I'll restart my laptop. That's the problem. Alright, so let's take a look at the for crying out loud, what are you doing? Is it not even running the shader? I can't see it pre-printed out, which means that this line is not being executed, but split objects is being ran. So that means this is 0. Interesting. What have you done? Right, I bet you this isn't... Right, that would have been a better one to do. Run that again. Get to do some optimization soon of some compute shaders. We're nearly there. Right, well, 2. So I've got 2 objects apparently, so the user is putting 2 out. So why oh why didn't I see anything print out for this shader? So it seems like we actually ran the wrong shader in the code. So I'm using the find ranges dispatch. What a wally. Copy paste. This is the problem with copy paste. Okay. Problem with paste is that you don't read over the code again. And then bugs have been inserted into your code base and they can sometimes get committed. And they're usually the ones where you scratch your head for the longest. Because you assume, alright, so I can get in it. Got some ellipsoids. Now I just got to see, like, if I go near the end of the edge of the screen, is there any sort of bugs? Because we did change some. I'm sure there's bugs. Seems alright. Yes, this is where the... Yes, the problem is, right, is the times actually spike. They spike up to like 10 sometimes. So it's really difficult to tell how long these things actually take. See, there's a 10 one. If I count up all of these, we actually only get like 4 milliseconds. So for some reason, my frame is taking longer overall, but every entry that I have doesn't actually add up to 10. So I don't know what's going on with that command buffer. Someone I need to investigate. Maybe it's something wrong I'm doing with the timing code. Oh, my damn laptop. Say something, probably hello, but Visual Studio crashed on, so I had to switch my Microsoft license for JetBrains product, all products license. Hey, Captain Chica. Fair enough. So you guess it made you rage quit. Hmm. How? Yeah. What made you go JetBrains? What was the selling point for them? I know, right? It's the code you assume the most. It's something I'm trying to be more aware of. I should just read code more rather than rush. But yeah, so it seems like it's all right. So this is where the bugger is, right? Tile bin ellipsoid takes 2 milliseconds, right? So it's the one that's completely horizontal from here. The section, the whole section, takes 2 milliseconds. So, but then if we look in here, the sort takes about 2 milliseconds. There's something wrong with those times. Why did the sort take 2 milliseconds? When you add all those up, that is not 2 milliseconds. And then the splat objects is 1.6. Yeah, I think. Right, I'm happy to know that the sort is actually quicker than that. So the number of objects that got emitted was 22,000 that are being sorted. So if you look at those times there, I don't think that's 2 milliseconds. I'm adding those up and it seems like we might get 1 millisecond maybe, but yeah. Anyway, then that was 1.6. Yeah, okay, let's read. That was one of those bad number frames, so when I had 10 at the total. This is 4 at the total. This one's saying 2 milliseconds, but I just see a bunch of 0.0 something. There's a lot of them. Maybe they add up. It's a bit like a shopping list when you get a bunch of small items and you're like, oh, this will be alright. And then it's like, oh, my laptop died. Yeah, maybe we can't trust these times. It would be nice. Maybe I can't trust these times. But yeah, I was gonna say the optimization we need to do is sort out those. You see that splat object is taking 1.6 milliseconds. That's because we're doing a whole for loop in a single thread in one compute unit. That big old ellipsoid there. So we've got to write different splat object shaders which handle edge cases like this. My problem is though that I don't think the timings are correct, so maybe we should investigate the times. All right. Yeah, all right. So let's maybe investigate these times because I'm a bit confused. We can write a slow shader and we only have one, and it should be consistent times, no noise between frames, and then we can use that to see if it spikes. And then if it spikes, we can also, it's a smaller command buffer, meaning we can track down what's being emitted and see things easier. Yes, I think we'll end up putting noise. Sorry, we'll put we won't write to the swap chain image. Yeah. This will be good. It doesn't crash off on the last code basis. Fair enough. Just the one you gravitate towards. That's cool. I didn't use Vim on Linux. Isn't it painful to use Visual Studio right now? Yes, it is. But last night I installed Arch on the machine again. So it's because I basically like bought a new GPU. I took it out, plugged it in. Manjaro died, and Windows survived, which is a shame to say. But I'm reinstalling Linux as you do with Linux. You always reinstall it. And so I got the old one on a different M.2 drive, which I've been just restoring. But I only did it last night, so it's not all set up yet. So hopefully next stream it will be ready to go. We'll hopefully get some time during my lunch tomorrow and Tuesday to do the final touches. And we'll get back running on Linux again. And using Helix and not Vim because Helix is the way. Right, I'm just going to quickly take a little break get a nice big old glass of water, and then we'll investigate these performance timestamp things and see like why the numbers spiking, and see if we can fix them and make sure the numbers are correct. You know, I know OBS is running at the same time, but it was still doing it for me even when we wasn't streaming. So I think we can probably rule that one out as the main problem. It still could be causing it though, to some degree. Right. For the tunes. Right, welcome back, folks. How you doing? Right. So I want to take that list and add these numbers up quickly, just to see if those times are correct, because I'm thinking they're false. So here we go. Right, so not program mode because it's just going to be doing just otherwise. 0.0014 plus 0.007 plus 0.00212 plus 0.00. Oh, I skipped one, didn't I? 2760. Oh, I've already messed up. All right. The computer's going to do it for me. How about that? For the power of programming. Oh. Right. Done. What is TMS? Time milliseconds. Alright, print. Alright, so if we run that, the number we're looking for is about 2 milliseconds. Is this 2 milliseconds? Let's find out. Oh yeah, I should actually put it in there, isn't it? TMS. I can't believe I tried to add those numbers up when I have a computer. Right, so have a look at the terminal. Terminal says, yeah, it's like 0.1. So clearly, the scope times were wrong. That's pretty quick. That was sorting. Well, it's not the same number. It was like 23,000 things. That's good. That's pretty quick. That's what we want. Good times. I like that a lot. Why is my damn laptop being dumb and disconnecting from Wi-Fi? How dare. Oh, yeah, Helix is written in Rust, by the way. It is, isn't it? Yeah. It's alright. Does a job. Most people, they fix the issues and those people reinstall git clone .files. I don't know if that's true. Like, yeah, Windows is typically more stable in terms of the OS. For a lot of like desktop issues, that's for sure. But I would also say Windows users live with a lot of problems. Yeah. Whereas the Linux user will have to go out of his way and manually solve said problem. Right, so we clearly know the times are wrong. So let's make the problem more simple. So when we do a sort of frame, yeah, okay. So what's the shader we're going to use as an example? Have we got a shader which does stuff? We do have those generate cube map shaders, right? Where are they? Ooh. Maybe we just run the initialization. So the initialization will do a what? Oh, you gotta be kidding me. But yeah, there's this sort of like generate pre-filter map. So I'll take this one. And we render these two. These should be a constant time. They take time actually, but they're a reasonable size. So I think I forget which one is quicker or slower. Where's the these only kick off once, isn't it? It's only when they change. So how about this? If I take this code here, where's frame start at? Yeah. So why don't we do this temporarily? Drop that in. Put a GPU frame submit. Submit that boy. And do a return. Hopefully that still runs. So we should... Oh, that means my profile is not printing out anything as well, isn't it? I think. Alright, let's take that code again. Duplicate up here. And really I should be putting this in... Remove me. I am test code, just in case I don't know, get lost. Let's put the profiling code in there. Remove scope. This is test code. Oh, right. So nice. We get our timing. So let's go over the whole tree and print the scope. Right. Good. Here we go. Don't need those dims anymore for now. When does people play games, next people write code? I don't know, it depends on the person, right? Do game programmers play games anymore? I struggle to. I get bored. Like, writing code is so much more fun. These look pretty consistent, but do they spike? Have a look. Yeah, I would expect a little spike, but you know, they're also taking like they're pretty quick. They took a lot of time on my previous GPU, which I thought was the same. This is just the next generation of the same GPU. Previously fix everything themselves, right? Yeah, so do Linux people. I write code for a video game on my Windows machine and occasionally playtest it. So, ever is right. That's cool. What game are you working on? Right, do we need to up the number of... Did I just change the dimensions or something? What did I do? Can I increase the sample? Is that passed in as a constant? Is that like a sample rate? I could have swore this took... Because it did every face on the cube map. I thought it was slow. Yeah, wait. Why don't I see them printed out here, eh? It's not even running anything. So, these are not running. Right, I see now. If statements. Copy, paste. Remember I said that? Right. So, we give it a run this time. We actually see some substantial times. Right. Okay, way too many milliseconds. Whole seconds, basically, do all this. So we would like to instead. So there's an upload that's happening. Every frame. Yeah, these things are taking quite long. The pre-filter map's quite a long boy. Cube map not so long, but and the upload takes some time as well. So let's get rid of the pre-filter map stuff. What takes time? Is that the generate or the render that takes time? Well, I don't know. Could have been both. So let's generate the irradiance map. Right, so that one definitely spikes, but it's at like 30 odd milliseconds. Isn't that a bit too much? We could do a smaller amount of oh no, they look pretty stable for a second. It is jumping low by a few milliseconds. Just the uploads alone might be enough, but I don't know if they're... Well, the upload is pretty consistent, but that doesn't use a... Right, let's take it down to like one upload. This is too many shaders. I wanted to simplify it to be like a shader. So... Right, let's do an upload and get rid of all this code here. See how long that takes. So we're seeing it spike here still. That it'll be weird, right? Will it? That's pretty consistent, right? That's the that's an upload. But you see that compute shaders waving a bit. So I think the upload will probably use like a bit of hardware to do that copy. And when it spikes up to about... Yeah, only this digit spikes because this shader changes. It's not that much. Right, so I think we actually need some form of dispatch, so we undo that. And if we take the problem is I think we use the upload, that's the bugger. But it would have been uploaded once already. So I think if we change this to a 1. It's a down sample though. Can I change that to a 1 and ditch everything else? It's a potential. Potentially, right? We get one dispatch, that's noisy. Right, I see some change. See if we can catch it. There's typically about 5.7. And then there's this sort of change. Yeah, it actually gets faster. It's like, no, I'm going to be way faster this time. But mostly they're about 5.4. Well, excuse me. So let's take a look at the command buffer and just really analyze what we're looking at. And also, do these times really make sense? And should we put a scope? We can play around by putting scopes around these and see, like, do the scopes also make sense? Takes cues from 2001. Oh, nice. Space Odyssey. Also, so I'm gonna say for now, that's all right. That's cool. Yeah, it's a good film. Interesting how long ago that film was done, and when you watch it, it's like it's still enjoyable from today, and it also doesn't look like it was filmed back then as well. Maybe we're watching more remastered versions now, but still interesting. Yeah, it's incredible, like how well that thing has aged. Right, let's put some profile markers around there. See if we can get it. Just put one around. Profile scope, that's what we call it. Yeah. Test. So this one should be identical to the single compute shader which runs. Right, so let's have a look. It's actually a little bit longer. Right, so there is a barrier that's in there. It could maybe be included in the barrier wait time. That is true. But also we could put an extra scope down at the command level. And we can test that theory. So inside the Vulkan code, be careful, get the right one. I don't even know what's going on. Be files open. Right, so when we do a command dispatch, if we just duplicate that, right, and it's just putting extra timestamps in, right? How does that? So it's gonna each dispatch is gonna have a scope around itself. Forgot to put this that. Right, take a look. Right, so the cost of taking the timestamp is evident. So there is a tiny cost for doing the copy of the timestamp, we can tell. Because the one on the render irradiance map on the outside, the outer one, that one is a little bit slower than the one on the inside. But then the one on the outside, the sort of test debug marker, that scope, is actually taking. So there is a barrier that gets put before, so it's probably from that barrier, and that's okay. So when we see these sort of see if I can find them, these quicker times, these are, it could be a cache thing, it could be a cache thing, it could be OBS running and interrupting the other ones, but these ones end up being quicker. Right, so I think we've concluded that there is some barrier waiting time, and doing timestamps themselves also introduce a very small amount of overhead, but it's not massive, right? But the difference in numbers that we got is still something we've got to find, right? When we put the numbers for the sorting had added up to like 0.2 milliseconds or 0.2 milliseconds for sorting 20,000 objects. But the timestamp number showed much bigger. Sorry, the group around it was the scope around it all was like 2 milliseconds. So something seriously weird is going on there, that's for sure. So I guess let's increase the amount of irradiance map stuff that's going on. So this is fine. We understand. So let's make it 4 and see if this test scope changes a bit. Hey Crimzo, I mean Linux, but I've had for less issues on Windows, that's for sure. I said I've further freedom adding, and developing kernel modules. Cool. As I wish, without random programs telling me they don't like them. Right, I didn't realize that was an issue. Interesting. Yeah, I didn't realize I'd never developed kernel modules. We add up these numbers. 5 and 5 is 10. And then that is like 8.4. So we've then got a bit of overhead. Probably for all of the barriers that get put in here. Right. Right? Because there's a barrier for each of these in this mode. Right? So maybe that could be it, right? If we got so many functions with, dispatches with barriers in between that always block, potentially then the GPU is going to definitely take longer, but I didn't think it would be 2 milliseconds longer. And then if so, why were the numbers outside? Were the numbers outside reporting that? That's interesting. Maybe it is maybe the problem is just barriers. So the timing of the shader is precise, but the timing of the group is wrong. Ah, so we might have to have different. Yeah, maybe. Right, I think we're onto something now. So the spiking might be coming from all these barriers, just the pure accumulation of barriers, which causes the spiking or something like that. That's my suspicion. Huh. What's the problem with the start function being at a different place? You do some like assembly or something like that? Right, I think that's a good suspicion. Always like having these assumptions and then testing them out and then figuring out if I'm right. Great. Great stuff. So, right, I think this is my latest assumption I need to test. So, how are we going to test it though? So, if there's a whole bunch of barriers, the problem will go away is if we don't put the barriers in, right? So we introduce another profiling mode, which doesn't put the barriers in, but allows you to emit. It still puts the markers down, or the scopes. It still puts these profiling scopes down. Yes. Right. I think we've found ourselves the test case, but let me just double check some of this stuff. Yeah, that seems legit. Right, that one's weird. Right there. That's the problem. Well, we've seen it right here. Why is that taking 26 milliseconds for this one scope? Barrier can't be doing something like that. It could be because yeah, I did leave the console taking ages, and then now it's doing this consistently. So maybe it could be just something to do with the console. But then that's CPU side. But is this just making the frame? Does this just mean that we're getting a slow number of submits from the we can have a play around with this without doing the extra without changing the code too much. It's in the Vulkan backend, right? If I were to go into the timestamp, what's it called? The timestamp, the right timestamp. Instead, let's do a few things like the compute bit. And I think we want to do like the transfer bit or whatever it's called. So we do those as well. And maybe copy the copy bit. Wait for those guys. Let's try and see what happens there. Maybe can't promise having two electron apps open at once and literally crashes my kernel pan. Oh wow. That's weird. This code is dangerous for you. Not really just hardware. Freaks out as it expects some. Huh. What's fun fact, the offset start from just 0 is usually native maximum size in bytes. Can be passed around as a valley. Oh. What do you mean by native maximum size in bytes? So it's like a 64-bit int, that sort of thing? Why does not one show? Oh, that is Crash Visual Studio, you son. Enjoying Visual Studio? Yeah, I'm enjoying it. Not. How long is JetBrains? Oh, I should probably just install Helix on Windows. Anyway, I'm going back to Linux very, very soon. It'll be good. But yeah, I should set up my Windows side of things. I come onto Windows very rarely and do very little programming, but obviously recently I've been here for like a week because of my Linux issues. Why am I being so silly? What am I doing? There's a... Oh, compute shader, right? You okay? You don't... Okay. Is there a copy one? Yeah, copy bit. Is there not a transfer bit? Alright, there we go. So we try it this way. Validation error? Can you not have multiple... Single pipeline stage. Oh. Right, let's just do compute then and just see what happens. So we're not got any copies that I can see. There's a good old bit count, or pop count as they call it. Right, so we're still getting the problem here. So it's not because we're bottom of piping at least. And that's consistent now. That's really wrong. Why is it consistently this bad? So if I were to put another shader after test, does it fix the problem? And it's a very difficult thing to figure out if that's fixed or not, because let's put bottom of pipe back in here. Oh, it crashed. Let's just see. Right, if we run that again, it's still going to do that consistent 20, isn't it? And if so, we can add the... Yeah, it's doing it. Right, we're good. So, go to here. Let's say the scope ends. And what ends up happening is we end up doing another one of these. Does that change how the scope works? No. So inside that loop, it still takes... So here is still 20 or about 20 milliseconds. Oh, no. Sorry, that is to be expected. It's not consistently bad. Right. Okay, so I guess we can safely assume then that it is probably the barriers that you're placing in. When the barriers accumulate, they create spiking. Yeah. So we can test this theory. So the theory is that we need to add a new mode to our, where is it? It's GPU.h. Oh, for crying out loud, just get out of here. Thank you, Tyler Beaver. Appreciate you. So this one is for benchmarking individual shaders. So it puts barriers down at the right place, but we need, so there's a whole frame one which doesn't, so maybe whole frame should be renamed to this is, we'll call it scopes. So we can put comments down. Very rarely do this. So places barriers down after each, before each command to ensure that only that shader, that command is running and the timestamps will accurately represent the whole duration of that command. Right, but this one here is just gonna put timestamps down. Right, inserts timestamps into the command buffer. Timestamps and barriers into the command buffer. And inserts barriers before. Right. So this one is inserts timestamps into the command buffer. But individual shaders, yeah, great for knowing how, for finding out how fast whole, I should really put a comment in here. This introduces overhead. So maybe we shouldn't even put, we shouldn't emit times on scopes then. Maybe. Oh, no, we'll still do it. This introduces overhead. So all scope times will be noisy between frames and completely inaccurate. Something like that. We've got to test the theory still, but I think that's the idea. Great for finding out how fast whole scopes run. With minor overhead with very minor overhead from from the timestamps being generated. Shaders will overlap. So overlap with others. So these will not be accurate. Yeah. So we've got to find the use cases of when. So I basically disabled the in gpu.c. I disabled. Run aloud. I disabled the there's a profile mode thing. Profile scope. It didn't used to emit the times for when you have it on frame mode, but I changed my mind. Oh yeah, disallow scopes, that's the one. So we get rid of disallow scopes. It doesn't need to exist anymore. So now they always run. Cool, so now this profile scopes will always be emitted no matter what profile mode it's in. So we should switch over to that different profile mode. So we go to individual, right? So I guess we'll make it a little bit more explicit. Well, we'll do this one as profile scopes. We should definitely make this, this definitely needs to be made some option you can toggle in the profiling UI, but I don't have that yet. So what we're seeing here, why don't we actually, yeah, so we're still getting the results, the unexpected results where, wait, no, are we? Yes, I think there's always barriers here. We got to test this theory out with right, I think let's go back to the old code and see if that fixes those scope times. Yeah. Wait a minute. So in the GPU, where does it do the barrier, individual barriers? Yeah, so that'll do that. Good. So if we, right, where's that? There we go. So if this code out for now. All right, let's take a look at these times. Okay, so are we seeing it spike? Well, I can't really. Let's go and make it sort of very. Increase the amount of entries that are going into that thing, right? So it's kind of steady around 3, but 4. Right, there's an 11. So, you know, this sort indirect is still 2 milliseconds. That is wrong. Could it really be all those barriers that are going down? Yeah, I don't think that theory is holding up. My laptop's playing up. I can't see chat. Restart it again. I guess that theory is still not holding up. So we added all those times up in this sort, this FFX parallel stuff. It added up to 0.2 milliseconds, but it's actually 10 times more here. Very weird. So maybe it could be that the so I guess the next test we need to do is let's just sort a bunch of data. Like let's just sort a bunch of data and see if it happens on something that's very yeah, see if it's happening there too. So let's go back to this one. Maybe I can copy paste it. We'll leave that old one. And then we'll do a sort. So I don't allow my laptops. Don't know if I'll be able to see chat. Let me get up on my phone. Which oh, it's not logged in on my phone anymore. I've got a new phone. Right, I'll periodically check chat. Right, we're still good. Good. So, right, let's check out this. So, I'll keep that there. So, we want to do a little bit of a sort. So it'd be like graphics sort. Let's just pass in that sort buffer, which should be initialized. Ellipsoid. No. Tile bin sort keys buffer. And let's sort. We can literally sort 20,000 of them. Let's see what happens. Should be alright. It's not doing much. So yeah, let's see if that causes the whole frame to be a lot slower than it actually is. Right, so the frame ends up being like 0.4, and then we randomly get there is one where it does spike up, I think. Yeah, I saw a 1 there. Ah, gotcha. So 1.8. Right, so the sort itself is a 1.8, but that's a 0.3 there. I would take those numbers. Wait, unless I do this. I never got far enough. There's a 0.7 there, we can look at that. Okay, we just missed the 1.8. 0.7. There you are. So we take all those. You I lost it. Oh, there's a 0.8. Oh, there's 1.3. Okay. So take all these numbers. What we got? Does that add up to 0. I don't think it does, right? But yeah, there's probably just a ton of barriers in there. But the theory should have been, and we put timestamps down. There's like barrier by barrier timestamp. But it shouldn't be causing it to be that slow. randomly. So I wonder, right, if we don't put the... Yeah, I think if we don't put the timestamps in, I don't think it's going to, like for those dispatches, I don't think it's going to cause us... I don't think it's going to fix the problem. But yeah, if I look at those numbers and add them up, I don't... They're not going to be 0.8, are they? There's barely any which is 0.1. Yeah, they're not going to add up. Right. So I guess let's add it just to see what the times are. So if I were to just simply... Did I get rid of that TMS thing? I did. Good. So let's just... Oh. Neat. So print that out. What do we get? The number was 0.83 or something like that. If that number's like, how much of a difference is it? Right, 0.1. So say if you put a barrier down between every single pass, is it really going to add 0.7 milliseconds every now and then? Just randomly. I don't think the answer is true, so we're going to extend this a little bit, and we're going to put more of these down for each pass. So floating point mantis for overflow. You think maybe? Because it's so small. That's interesting. So what? Huh. Right. Let me have a think about that. So where will we so when we convert it to a yeah. Let me call that it. Okay. So every iteration will do our own little... Yeah, it does go down to... I think we change it. Right, see if we can find a spike. Right. If you look at these times, that one's a 0.692. So uh 0.692, yeah, so then the other ones are like 0.3s, and then does that really get you up? So the three of them will get you like 0.1, another three, 0.1. Yeah. So you're still off by about another 0.1, I think. Very weird. And there's no barriers in between it. 3 there, 2, 3, 4. So that's one might accumulate to 2. Yeah. Right, I'll check that how we're getting these floats. as well. Yeah, we'll check that one. Thank you, Captain Chica. Let's have a look. So, how do we do this? Let's have a look. Yeah. So, right. The way I think we do it is we do it. We convert to float 64. So will we overflow that? Momentus are on. These are nanoseconds. I guess could we turn it to microseconds before we make it overflow maybe? Yeah, alright, so I guess we could test that theory out by already dividing it as an integer by 1,000. And then we could divide this one by... Right, let's try that out and see if the frame times jump. So... Right, I saw them jump still. The frame is called total, isn't it? Yeah, total still jumps. Yeah, so it's not that problem then. There's something else. Do barriers really take that long? It could maybe we need to check a third-party program. Or what's the best Windows profile GPU? Right, what is there's like a tool you could use, I remember. Does anyone know the... See, I could get the Radeon one. Oh yeah, it only works on Windows, so maybe we should do it today before I get off of Windows. If we profile it, we could maybe see the... It might help. It's an AMD. Can you profile in RenderDoc? AMD 7600. A76600. Right, so I think I can just run this. Gotta figure out which exe you run, isn't it? Oh, you bugger, you extract all. Please. Yeah, AMD processor as well. I didn't think why that would help. Yeah, I got an AMD card. So it has to be AMD tools. But there is a way, I think there's an old school sort of profiling tool built into Windows, I forget, where you can check sort of the overall GPU traffic and what's going on. Yeah, I think there's one of those there, but this one will test our application. Right, memory ray tracing analyzer to profiler. See if this works. Oh, for crying out loud. I gotta read stuff. I remember sort of reading it. It just sounds like rocket science. How to capture a profile. Right, let's keep it in here. You got RTX 4070. Cool. Yeah, I guess you just use Insight for that, isn't it? Seems like a lot. Right. Develop a panel. Capture, put your application in. Right, develop a panel. Right. Capture. Profiling. Get out. What you saying? Status offline. Oh, this is the other thing that runs on Linux, isn't it? It's that. Need to add the applications to panel or something. Do it. Game. You're on the service as well. I guess you run it in the command line. Don't know what's going on. I can't select anything because it's offline. Right, let's find a different tool. This one is like rocket science, and I can't just figure something out without reading a whole download of documentation. Start the panel. Set up a new connection. Oh, it's green now. Right. Did you put a host name in there? Oh, it's connected already. Cool. Local connection. Alright, so it's got one. Change to green. Neat. What's next? No, no remote connection. Capture. Go to capture tab. Add an application, right? Add profiling, yeah. Presets, we don't have presets. Automatically connect to an application that is using the API supported. Right, I've got to put in a name. So if I was to run it, what happens? Ah, it shows up green. There we go. Right, okay, so I did a capture. Right, now we've got one of those. Double click it. Alright. Now we can see some more times. Oh, render, you can do capture profiles. Right, but it must be doing it the same way I'm doing it with timestamps. But that could be an interesting way to see how different the times are from mine. See if my implementation is wrong, maybe. Could be it, right? Right, so it's done what? It did a few frames. Ooh. Right. This is interesting. So the command buffer, and what's all that in there? That's the actual graphics queue. I don't understand the graph. So when it says frame, that's... I'll zoom in on this. Right, I see. So there's a present. Okay, so it's v-synced. Right? Right, so it is v-synced. That is true. But can I break down this command buffer thing? Like, so this command buffer length, it does vary, but I guess they schedule it so it hits the vsync, but I can't think they could do that. They must run it. I don't know. I'm confused. What software is this? This is the and hey there, Cat, by the way. This is the AMD GPU Radeon profiler. It's a little bit difficulty. Well, a bit weird to use. You have to sort of like make a connection and then open up a few programs, but we seem to figure out quite quick actually. But it's got to figure out like what things mean. Basically, trying to digest this information. So I think another suspicion could be then that we're actually waiting on VSync. So could that be having a mess around with our timings? I don't know. So let's try it out. We've got the capture and still. So I think we have VSync. So we create the swap chain. We do. I think we're still using FIFO because. Right, FIFO and then. Yeah, that's VSync, isn't it? So if we did immediate, what happens? Does it our frame times? I don't see any spiking anymore. That is strange. So is it? I guess we can figure out why that is. Wait, was that quicker? Did I just see a 0.01? I missed it. No. Different one. Different shader. That's consistent. So it seems like VSync is causing the frame to get... Ah, right. So the present will happen and then signal, then kick. And then this happens to finish here. What's that? Is that a present? What are you? That's another present. Part of the present. Right, that actually does the flip on time. Right, so I think it's the VSync thing. It's interesting. Right, updates in chat. So I think we've found out what's going on with these times. So if we don't do any of this silly stuff and go back to the actual game, I wouldn't think they would play up with the right. I'm seeing the times go up, but it's not like jumping to 10 milliseconds anymore. And that sort time looks reasonable. 0.02, doing all that. Well, not really. If you add all those up, that's not right. But it's definitely better. There must be all the barriers then. If that number stays the same, sort and direct, then it must mean that that's just the barrier overhead. Right. But sorting 20 well, okay, we'll figure out what it is in a minute. Let's go up to here. So this is a full screen now. How does it look? Yeah. Get that there. It's kind of full screen. Let's make it wait for it to become wide again. There we go. So sorting all of those is about 1.8 milliseconds. If we look at all of that though, that's not 1.8 worth, I think, if we add it all up. Not going to be that. Wait for it to go again and check. It's in 1.8. So I guess all those barriers. It could be. Oh. No. Right, so maybe we'll do another capture here because I'm a bit confused. The times are definitely not noisy, but I don't think these. So this is where this profiler thing is going to help us actually crack down what's going on. So where do we press the button? Here we go. Go. All right, got a new one. Cool. So we take a look at this one. Right, that's the old one, isn't it? I think so. This is the new one with immediate. No, it isn't. I have no idea. Right, I don't know why there's a wait. Why is there a wait? So in milliseconds, that's micro. Yeah, so it's 30 milliseconds. What's that? A wait. Present. Right, okay, so let's just keep tracking all those. Just saying it takes. Why is it still doing all that? Different 1% of your application's time is consumed by barriers. Right, so these are all micro. Can look at that, see what's going on. That's pretty cool, get that information. So in the command buffer, can I get granularity of the command buffer? So 65 barriers and then 34. All right. Okay, so we're still getting this weird. I don't understand that. Like, we should be using immediate in this capture, and but we're definitely seeing the right one because the number of calls was big. Most expensive events. Can you name these things? Yeah, it should be names. I've got the pipeline stuff. It's interesting. You get a lot of information here. Most is 5% events take 8% of the time. All right. Work duration, that is nearly a millisecond. No. Yeah, it's nearly a millisecond. We don't have a 1-1 which takes nearly a millisecond. That's the setup ones, isn't it? Up. Frame minute, that's cool. Where have we got these 1-1s? So we do one, right, couple of setups. Frame minute. Yeah. So there's only those ones which just basically copy these basic things in. They're not nearly a millisecond. Strange. Oh, these are using vertex shaders and fragment shaders on the hardware. Huh. Do a copy image. Interesting. Oh, what is this? Did it really take that long? Why? I'm reading that right. That US means microseconds, doesn't it? Right, compute past 0. Interesting. Right, events. Wave occupancy. Right. There's so much information here. Wow. So, this one here is a bugger, apparently. Can you tell me which one it is? I've got the debug markers in there, or whatever they're called. The the ISO. You can get all your information. VGPRs, SGPRs. Nice. Can't be the one with the if statement in it, right? But yeah, so if we go from the start, there's the first one, frame in it. Then there's a few ones here. What do we have again? So how many setups do we have? So let's count them. 1. We should be able to see the name here. I don't know what's going on with this name. You probably got to use the AMD marker extension. Can we use that? Let's find it. There's a Vulkan extension called AMD marker. I think you've got to use that. Vulkan AMD marker. To write small marker values to a buffer object. The primary purpose is markers to facilitate development. I think you've got to use this. But what? Why'd you put it in a buffer? No. That might not be it. Yeah, I wonder, is there any sort of like documentation on how we get better names? It was in that docs thing I closed, wasn't it? How do we get lovely names in there? Why can't you just use the debug names? The Kronos ones. What's it called? The Radeon profile GPU profiler. Debug names. Export shader names. Maybe that's part of the actual capturing tool. But I've got... don't think that's it. It's instruction timing. But yeah, see, they've got like sphere intersect. So... Right, that's not on B obviously because I didn't put instruction timing on. But we should be seeing... When I bind pipelines... They're right here, right? What the crap is this? Wow. But yeah, I'm just seeing like the disassembly of RDNA 3, which is pretty cool, but I'm not seeing anything like a name of the shader anywhere, which we do have the debug symbols for that. It's a bit weird. Oh wait, we don't have debug symbols in our shaders. But we do have the... Yeah, there's definitely some form of names in there, but not per... No, we might have lines. I forget. But still, we should be able to take it from the command buffer. We've named our pipelines. That is weird. Does it support... What's the extension that we use? Object name. That's it. See if this... Right, seems like they support it. Debug utils, I use that one, right? Yeah. Exactly. Well... This sucks. Actually cannot tell what shader it is, but, well, no, I can probably tell. It's got to count the number of ones there are, so... yeah, so frame init is one of them, so that's one. Next one would be tile bin setup, that's another 111. Two, so the next one is splat setup, cool, 3. 4 would be indirect args. And then the next one would be indirect args again. So indirect args is, why is it taking long? What's the blue mean? What's the time it takes long on? So apparently it's saying that this one here, I think. Let's take a look. Or this one. Ooh. Could be this one. Only one of them is set up with this. Yeah, it's this one here at the top. So, if you take a look at the times again, set up indirect args. Yeah, so frame init 2, 3, 4, and then we do another one. Then find ranges setup is 5. Go back to here. 1, 2, 3, 4, 5. So it's saying it's this one. I don't get it. Why is... So it's saying it's the find ranges. Right, apparently this is taking a very long time. Right, executes both sides of the if statement probably. No, just one thread. I don't know what it's saying. It's saying it's taking like nearly a millisecond, right? A long time. Can't get those to click. Very weird, very weird, very weird. Right, so I guess let's recap. The times of the individual shaders seems fine. We just can't figure out the scopes, why they're so much higher. If we add all those numbers up, they're about 0.2 milliseconds, but they're kind of like nearly 10 times as much in the scopes on the outside. So sort of indirect ends up being massively bigger. So I guess we could do another profile quick. Let's delete these two. So it's still running, right? Collect counters. Delay capture, no. That's instruction instrument, and maybe we can, let's do that one. Try that. Looked at kind of a crap time, to be honest. I didn't know how it compared to the... Right, I just missed my window. So when this expands the whole way, it's the slowest. I'll do that. Neat. Let's take a look at that one. Right, so we look at the events. Excuse me. So where's the slowest one? That's it. It's there again. Oh, this one wanna... I suppose that blue mean? There's kind of like different colors. Right here. What are you? Right, can't really see much. Right, so there's a barrier there as well. And the barrier's waiting for as long as the actual thing to finish. And then the other one kicks off finally. And there's a little bit overhead from the barrier, right? 100% spend times there. Right, okay. We got the instruction timing. Come on, I put it on. I'm suspicious. Select an event. It says average wave. Oh, yeah, yeah. Oh, we're launching 32 of these. Oh, that's suspicious. Ah. We're launching 32 of them. That was see where the spike. Whereas the find ranges. No. Bunch of ones. Total thread groups. Thread group dimensions. Ah. There's 32 of those. Where's the 32 one? One. Oh, there's plenty of those, isn't there? Right, so I think what we're doing is we're launching the wrong... Right, so where are we doing those like this? Right. I think we're on something here. That's just a single thread. Right, there's a scan here. Right, we only launched that once. Okay, so it's a scan, that's the problem. This scan is doing a prefix. Right, but that's just part of the sorting algorithm. Okay, so it's launching, is it doing any for loops? 4 times, 4 times. This is just AMD's parallel sort thing. I think we got this right. But so what's interesting is there is a prefix. The scan prefix function is called different times. There's like a add sums partial. Yeah, it's still the same sort of code. So that scan prefix. Right, I think there's like a barrier in there or something. And then this runs by itself, and it has to run. Right, I think I've got an idea what's going on. So this scan takes time, and it stalls. So if we isolate a barrier, sorry, if we put a scope around that, we should be able to tell. Oh, we've got to put it on the right one. Yeah, it got me some ideas now. So we should be able to see the times with these markers or these scopes. So it's happening on an indirect with payload. We put it around the scan launch here. Now if we look at the profile information, we should see the barrier up in some of the timings maybe. Right. It's interesting, it's like a sort of crash analysis thing. Yeah, this tool isn't actually available on Linux, it's only available on Windows. So if I want to do any heavy debugging, probably best to switch over to Windows in that case. It's a shame. But yeah, so what we're looking for is these times. There we are. Right, I'm thinking this its time should be massively different. Right, let's include some more things. Let's include the one before it. So the one after it, I meant. Because that means there'll be a barrier which goes down here, then a barrier here. And then... No, I still don't understand how. But also the times that we're getting reported are really not as long as it's saying it is. Yeah, so we did 2 there. And then like 0.6. So that's not really correct. There's definitely some overhead there with the barriers. You can see it. But weird. Alright, let's extend it out a little bit more. So we did it actually per iteration. Let's see how it looks. The per iteration of sort. Get in there a bit. So for each iteration of the sort is 0.03 apparently. So if you add those up, there's like a kind of 0.01 there. There's a lot of barrier overhead happening there. But if we add all of those up, do we get 1 millisecond? That is a big no. I can't see the times that they're talking about for these. That's not 1 millisecond. So we do three of them, that's one. That's a 0.01. And then another three is 0.02. So it's about 0.03 at most. This is very confusing. So if I slap a big old one around the for loop, let's see that. And then there's this indirect here, which I don't think pausing. Right, this is making it behave. Yeah, this is making those times behave, so maybe my code is wrong. That does the marker things. 0.17 that it's with an R on the end. Is it perhaps right? It's a small QP. Huh? Okay. I think once you get Helix and everything is smooth, you forget you're on Windows. Right. Huh. I don't know. Maybe. Because the problem is I'll still have to use Visual Studio and boot it up in there for the debugger. So I think I won't forget. Let's remove these individual it things. And just keep the one which is around the whole loop and see if we get, see if it still fixes the problem. And if so, it's something weird. Got to get close again, isn't it, for it to be kind of. Right, let's take a look at that one. Yes, it's a with an R there. Is that nah? It is actually 0.19, and that is closer to what we Yeah, we added all of them up before, and it was something like that, wasn't it? Cool. So if we add another scope around here, call it yes. So if yes isn't the same as this one, like it's the exact same scope, it just adds, like, then something really weird's going on with the timestamp stuff. If not, it might be something to do with that other shader. Right, yes is the same. Wait, it fixes. Yeah, it fixed the one behind. Right, so that code doesn't tell us anything because it fixed the sort and direct times, made them behave, which is horrendous. But if I remove it, undo the stuff we just did, and run it again, we'll see that the sort and direct scope is actually like a millisecond. Right, why can't I see anything? Right, there we go. Let's get a bit closer. See these times. Yeah, so on direct's like a millisecond here. Like, what's going on? That's not correct. So I think what's going on is it ends up using the one at the end of the frame and takes the difference. Or no, because the tile bin one is kind of the same, just a little bit longer. But maybe that's got the same problem because it's a scope thing. Yeah. Right, so my suspicion is that there's a problem with the code in how we generate the timestamp scope things. So the way we're linking them right, so when we do that sort of profile scope thing, push and pop, I think it's the way we are doing this sort of logic here maybe, or maybe it's in the, let's just double check it. So right, so every time we push, we basically allocate ourselves a scope, chuck all the bits in there, and we're making a tree out of this. And then at the end, we're going to pop. We go to the parent. So I guess here, and then we end that one, which internally just records another, stores it in the end index. Right. Right. And then, okay. Yeah, stores it in the time end timestamp. Right, that looks sensible to me. So we take a look at that. When we extract them out, we get the start and the end, yeah. And then you're just pulling them out of this timestamps thing. Maybe we could be off by one frame. The whole timestamps thing is just wrong, but I don't think so. It could be a problem, right? So let's see if this is push pop, and you want to be looking at the yeah, if we print out all the timestamps, here's how we'll do it. Yeah, we want to print out all the timestamp indices. So I think temporarily we'll just put another U32 in there. We'll call it timestamp start index and end index. We'll actually have explicit ones for this rather than reusing it, so we can debug what's going on. So we'll simply do something like this. Yeah, so whenever we record it in Google Code. So that means in the when we actually debug print those scopes, we should be able to just put out a number or a couple of numbers to say like, hey, these are the ranges. So we'll just say something like, you know, there to there. Right. And we'll say scope, timestamp, start, scope, timestamp end. We try that. Should give us enough information to see if these are wrong or correct. Oh. Sweet. Oops, there's a double paste. This file's in a bit of a weird state. Because this the second one that's been opened or something dumb like that. Right, so we just take a look at the timestamps. Is all we care about. Like, are they the right ones? So if you see sort indirect, that goes from 22 to 105 timestamp indices. Then if you take a look at the end, the last one is 104. So yeah, it seems like that is correct. And the times that are being shown are actually kind of correct here. Shoot. What do we do? But it showed like 1 millisecond, didn't it? Before in the past. Right, let me go back to here and re-put in those sort indirect. So let's re-put these down. I think I put it here, or like it or something. Let's re-put those back in there. Let's see if that causes the sort indirect to be times to be wrong. That's not sort indirect. Right clicks on sort indirect. Hang on a minute. Undirect with payload. Alright. Okay. So hopefully these times are actually wrong, and if not, I don't know what I've just done to fix it. Very bizarre. Actually though, we wasn't close up to the object. That might have been it. Oh shoot, let's get close. Alright, let's see this. It's actually got stuff to sort now. And let's have a look. Right, so that's where it's wrong. It's going to 107. So it's definitely after that one. Yes, I think the way the timestamp ranges that it's getting is definitely correct. Because sort args, the sort indirect args starts at 23. And the final one here, which is iter, ends at 106. You see this one's 105. So yeah. Seems like it's getting the right numbers. My concern though is like, right, let's see if we can fix it by making it take away one from the marker and using the one before it and see if it works. See if it's just the end. We can see if it's the end of the if we take away one from this end index, we can see if it's the end index which is causing the inflated numbers. That should do it. At days. Rightio. Yeah, so he used the one before, and so that means the times of the shaders are going to be 0. But what's interesting is the sort indirect is still long, which means it's as if it's the barrier for the indirect args, which is just taking a long time. But we don't know. um, it's as if the barrier that gets inserted at set up indirect args is the thing that contributes to that long time. Which is waiting for the splat objects to finish, maybe. Ah, that could be it. Right, I think I might have figured it out. So the problem is the scope is put before the barrier that gets placed in. Ah, I think that's the problem. Right, let's undo all this and we can... Right, so I think we found 2 issues today. It's really good, that's really good. Right. I'm just going to take a quick little break and when we come back, we'll go over what the issue is. Right, welcome back everybody. Yeah, so I think let's just confirm my suspicion is true. Is there a barrier that gets put down before the indirect args shade, the one that populates the indirect args, right? Is there a barrier that gets put down here? And if so, then suspicion is maybe true. We got to carry on checking if it's true though. So we go into here, we do a sync. Right, we're always syncing on 2 resources actually. They're the right, which means a barrier goes in. Ooh. Right, so barrier definitely goes down. So the curious, right, this we've always got resources which means is there always barriers that go down, probably. Even if you got the other profile mode on. Damn it. So those always sync resources, that's definitely a problem. Let's put a pin in that and come back to what we're thinking about. So the problem is that the barrier, that the scope gets placed down before the barrier, and if the barrier actually takes a long time to, like, it's waiting for the previous shader to finish, right? So you want the timestamp to go after the barrier. So I think that's right. So what was the times? So when we get really close, yeah, this is it. When we get really close to the object, the previous shader that runs before the sort takes longer because it's splatting objects onto the screen. Yeah. This is it. This is it. This theory is definitely right, I think. So if you take a look here, we've got tile bin ellipsoids. That takes, oh no, sorry. Yeah. Inside that scope, look at the sort indirect. That takes 1.6 milliseconds, but it doesn't, because before that, this split objects takes 1.4 milliseconds, right? Because that one takes long, the barrier that gets placed before the FFX parallel sort set up indirect args is waiting quite a long time. And that's the problem. Man, that took ages to figure out. But it's got me thinking. Got me thinking. So, if we're going to be explicitly placing barriers down, they need to be placed. And if you put these scope things down, right, so if you're doing these scopes, the scopes should really be placed down after a barrier is placed down. So on the next actual command is when you should do a scope, but there could be many scopes. So I think we need to build up a list of scopes, and those will then ignore the barrier, and then we don't have to, yeah. So we should really have an array, right? Right, let me just quickly delete some of this crap. And in graphics it would, cool. Let's close that as well. Right. So inside GPU, we need to have a little array of all the scopes. Started profile scopes started but not inserted but not emitted. Perfect. Oh, but not. Neat. So when we do our profile scope push, instead we're going to do a core stack push back, or push many, looking very C++y there, on our super lovely array. And we're going to push back a scope pointer. No worries, stable pointers. All good. Then, later on, after we do... So, there's a bit of code. So, when we do a command dispatch, it's got to be super careful. Right, so after we do these, we only do them if they have any, so we've got to be... we're probably going to make another function. And it'll probably be called... be careful. Command try emit profile scopes. Bit of a, maybe there's a way we can, you know, thinking about it, it's due another function. So I think this code here is just it just needs to be in a function, and that's the problem. So it needs to be like a command. Something happens before, so you got finalize at the end. So we want to command prepare. Beautiful. This is going to be it. So I have a command prepare, which we'll put in the right place in just a sec. It is going to do this stuff, where it goes over all of the always sync resources, maybe puts the barrier in. And then after that, it's going to do another for loop over all of those. Over all of those profile markers, scopes started but not mid. We'll get the GPU profile scope and bend command see, it's actually a command. Yeah, I don't know. Puts into the command buffer, doesn't it? Yeah. So maybe that should be renamed to command. Do that quick rename. Like, how else will the implementation do it? It's got to go in the command buffer. Cool. So we do a start. It will actually do it, and then we clear the array. Got to be careful about that. Clear the array. If not, we'll just keep inserting the same ones over and over and over again, and it just explodes. So now we want to call a prepare before every single actual command. So it has. So we want to just find every time we do this sort of command resource barrier. Oh wait. Let's put this in the right place as a finalize. Let's put it next to that one because in the header file it's next to that one as well. Neat. So let's look out for a finalize basically, and we'll put in a nice prepare. Right, so it does an explicit sync. See, I'm a bit concerned. Yeah, good. Oh, it doesn't do the always sync resources for these guys. Whoops. Always sync resources are actually probably part of dispatches only, not any of these special yeah, not any of these special operations like buffer zero, stuff like that. So maybe I'm glad we're getting rid of all this. Maybe we'll pass in a boolean, or maybe we'll copy it out. Prepare after that. Right, so these always sync resources. I think actually we'll take those out, stick them in here because they're only really for. I could put an if statement in, but no. But the prepare must go before the dispatch. Realistically, it'd be nicer next to here. Cool. So many functions. There's not that many. Alright, nearly there. We're literally there now. So, always sync resources, cool. That should be it. Fingers crossed. Yeah. Right, so we try that out now. Oh, let's initialize the array still. That should fix our spiky times. Maybe. Do we initialize it to whatever the profile I want is? Where's all that stuff? Yeah. Initialize the global array. We've got to, it only initializes once. See the maximum number of scopes that we can have. Oh yeah. Oh, it's be good if my frame times are consistent, and now that'd be really good. What is this? Oh, I need to make that a, hang on a minute. We could put indices in there instead. I've got one of those. Ah. Yes, put indices in there instead. Yeah, so these need to do an address. So just as an extra addition. Profile scopes. No, I'll do the type def. I think I've got to get an, do something extra. It's a bit weird. So wanna. It's in the public header. There we go. We'll do a single push. Oh, I shouldn't be calling that start function. We need to type def ourselves one of these boys. Maybe it might be useful. Nearly there. Right, so this should be the profile in times completely amended now. Let's have a look. Crap. What have you done? It's not ready? Apparently we buggered something up. I don't know if this is the first frame or not. Well, we could tell actually. We've got a little counter in there. frame index somewhere. 2. Right, so that is the first actual frame that we're rendering. Right. Let's have a little look what's going on here. So the barrier's always going to go down, I think. Rest is on the first clear. And this one is clear. Oh shoot. This means that the clear... no. This is bad. The copy of the yeah. The problem is the backend does this internally, you see. The backend right here. Oh, where is it? Here, it will... Oh, no. Whenever we do a dispatch... Whenever we do like a dispatch internally, we end up calling that start and ends. So that's going to put it on the queue, and then it's not going to actually get recorded into the... yeah. We could call like the prepare though, or whatever, where it just goes over and does it, but it's weird. I wonder if there's a quick fix available. But that is an issue. I'm in too late. I wonder why though. It didn't run. Wait, it's caused me... I think we've put some of the starts after the ends or something like that, and it's caused something weird to happen. Yeah, not good. Okay. I wonder what we should do next. So we put these starts in before the command. Yeah, so we're trying to stop a... It's got to be instead after the barrier. So we defer it. Until after barriers. The other way we could do is reorder the barriers around. So we order the barriers around such that... No, you won't know. So we might have to put a bit of a system in where we check if we're kind of internal, which would kind of suck, but yeah, it's possible. So what we do is we say so inside a sort of a prepare, so after prepare, we put it in a mode where we say, hey, we're in. Yeah, that's what we'll do. There'll be a boolean say emitting. Right, so by default you'll go like this one goes directly in. Yeah, so is emit command equal true. And finalize is false. And then when you do a start, scope start, or push, you go, well, if is emitting a command, you actually just do it right away. If not, you defer it. Not that much more code. Should fix the problem. I'll do it. Right, fingers crossed. We're getting the same damn problem again. I don't know what I'm trying to get diff on it. Probably mess something up. What do we change today? It was prepare thing. Sure. Yeah, that's fine. It's fine. Fine. Removing the resource pair and putting in the prepare instead. That's all right. That's cool. That's still okay. Yep. Right, I don't see any problems from any of those. Alright. Just shader code from here. Right, so saying on the first frame. No, it's on the second frame. We've checked it. Equal to something. This is the initial one. And it's not ready yet. We should have waited. I wonder what happens if we just don't collect any timestamps. Does the code still run? Alright, timestamps are going to be wrong, but the code still runs. Why is it not ready? That's the weird thing about it. That's not a set on not ready. An if statement instead, but still weird. Still think we're emitting them fine. Right, so we go up close to the screen. Has our theory been confirmed or validated? So here we go. That seems alright, doesn't it? See those time. Oh no, the upload command buffer is completely wrong though. Right, so that's where the problem might be coming from, is the upload command buffer. Let's undo this one. Sorry, not upload command buffer, upload, yeah, command upload buffer. Yes, what I meant to say. Right, it's still got the old code here, which means the prepare didn't go in. Right. So something weird happened. The GPU prepare. So there's some timestamps which didn't actually go in. There's no finalize here. Yeah, why isn't it finalize? Right, that one showed up in the profiler then. Oh, sorry, the texture viewer. Well, it's for a buffer, that's why I didn't put it in. Right. Okay. Alright. Upload. Technically it shouldn't show. Alright, I think those are the issues. I didn't go through all of those. Hmm? Well, still on the return. I think at least. Is alright. Cool, let's keep going. It's on the read back. Another one apparently. Ooh. Cool. That's it. So there's only one of those now. Nice. Maybe we should change that function, how it works. Put it as part of the prepare. Right. Seems to work there. Nice. So if we go up close here. Ah, oh, finally. Okay, wait for it to go around again. So now there should be stable frame times in the profiler. There we go. So sort indirect is now only 0.19, which is pretty good considering we're sorting 22,000 entries up there. So that's pretty good times I'm happy about. Although the splat objects is what is slow, and that's what we wanted to optimize today. Unfortunately, we didn't get a chance to do that. But good progress, because now we know that these profiler scope things pretty much correct. I've got something fishy with the always sync resources thing, which will end up causing what do they do? They end up putting barriers down anyway, which means you still get the barrier overhead. So there's always sync resources where they always sync on the debug draw stuff. they're just always available. So we can just yeah, so we can just use them in a shader basically. Yeah, it's a little bit weird. Right. Say you use an older API like DirectX or OpenGL. How much farther along do you think you'd be over a Vulkan game? Oh, check over introduce this. Thank you. Don't do this. I don't know. So I'm only using compute shaders, so it's not that more complex. It's not massively more complicated. It removes the whole rasterization side of things. I'm putting a lot of my work into compute shaders rather than this Vulkan backend, because I'm doing it a lot of stuff manually, which the GPU would typically do for you, right? Yeah, the cert's still in there. Sweet, thank you, Valubus, or Valubus. Yeah, so I don't know. I can't really give you a definitive answer, but Vulkan is definitely a lot more of a cleaner API, but it is definitely more complicated. So yeah, and I knew Vulkan more over OpenGL because I've been using it more recently, and we just went for a very simple implementation. So yeah, this is only like 3,000 lines of code, which is, and it's got a memory allocator, custom memory allocator. It's got a profiler. It's got yeah, it seemed pretty functional backend. We've just assumed a whole lot and generalized it. That so for instance, when we create a buffer, there's a fixed set of usage flags, so these things don't get passed in. Basically, they don't. This is internal. So that when you create a buffer, you just say I want a buffer of 2 gigabytes, and that's all you need to pass into the GPU thing. So I've just assumed a whole ton and simplified everything. That the Vulkan backend isn't really that complicated. Yeah. Right, so the only thing we've got in question when it comes to these profiling things, which isn't really causing any bouncing in the times, right? Any spikes in the times, is the always sync resources, but I think we're okay with those. I don't really care that there's always a barrier going in, but we should be careful about that. Because the profiler, maybe we can remove those resources, I don't know. There's something to question about. I'll think about it. Right. So next stream we should be on Linux. So I'll put this code up on the repo tonight. Thank you so much for everyone who's supporting me and gets access to that code. Appreciate you guys. Yeah, I guess I can drop links for that. There's spawn code file Twitch. Get access to the source code there. Next stream, we're going to actually do the optimizations for those splatting of the tile bin entries. And then maybe we'll get started on model instances. We might get started on that perhaps, or I might see if I can get rid of this problem here or something. But yeah, right, it's an interesting stream. I'm glad we tracked down those problems. That was crazy. We learned about this tool, this AMD control panel thing, AMD GPU profiler. Interesting. Didn't learn everything about it, but just seeing a range of things that it does. That's cool. Right, I'm gonna bail. It's a bit late. I need to eat food and crash hard. Okay. Have a good start to your work week, guys. Hopefully see you all on Tuesday or Thursday next week. there'll be a stream about 4 hours ago on those days. And there should be one next Sunday as well. Right. Catch you guys. Have a good one. Bye-bye.